Good morning. Welcome to the third day of Tango community meeting. I hope you could rest after yesterday night. Sergi is about to come, so I will introduce the first speaker. Sergi will be the chair of the session. We continue with the community tools and projects. And the first talk will be by Sebastian about the Tango Control infrastructure automated laser alignment at CALA. Yes. Please welcome the speaker.
So, hello, my name is Sebastian. I am a student assistant at CALA, so at the Center for Advanced Laser Applications. And today I'm going to talk about how we use Tango there and about an automated laser alignment system we built ourselves. And just to give you guys a quick outline, so we start with an overview about what CALA is and with a few facts about Tango there. That I'm going to explain the alignment system we built there and how we monitor and control not only the alignment system but everything else. Yeah. So what is CALA? So CALA, or the Center for Advanced Laser Applications, is a university lab in or close to Munich, and it's actually run completely by students. So not only the research but also the Tango development and maintenance. And there we have the Atlas 3000 laser, which is a titanium sapphire laser. Here you can see here, or at least the amplification stages, and we can produce pulses up to 60 joules with a duration of around 27 femtoseconds at a rate of 1 hertz. And theoretically, we have a power of 2.5 petavoids when we are in peak. And this laser can be directed into multiple different so-called caves here on the right. And we have 4 different research groups there: Lion, Lux, ETTF, and Spectre. And yes, so to manage all this, we of course use Tango, and we only use Python and PyTango there. We have around 800 devices and 5 different Tango hosts, 1 for the laser and 1 for each research group. We run 9 virtual machines, 40 Windows hosts around, and 9 Raspberry Pis. And because we have a rate of 1 hertz, so we have single shot operation, we do archiving always once a second of all the text files, measurement data, some pictures we take, which can be around 300 gigabytes a day. And all this is not only maintained but also developed by our PhDs and student assistants, where we get a lot of help from the university at HIJ to build all this. Yes. So one thing we use this for is the mentioned automated alignment of the laser. And why do we need such a system? Because as you can see here on the big picture here on the left, the laser starts here on the left, and before it actually reaches its target somewhere here, it travels a very long path through all the amplification stages and the main amplification stages here in the middle. So every time we turn on the laser, we need to actually align a lot of mirrors to always point it in the same spot in the same direction. And this takes us a lot of time. And to save this time and make this more reproducible also and automated, we built this system. And how it basically works is we have 2 cameras, the near field camera for the beam position and the far field camera to capture the direction of the beam. And then we look at those 2 images. We calculate the position of the laser beam on this image here with the red cross here. And then we compare this position with our target position where we want our laser beam to be. And if it's bigger than a certain margin, this margin we call target region, then we want to perform a correction movement. This means we calculate how much do the motors need to move the motorized mirrors. So we actually have the mirrors here on top, which are there to actually move the beam and change its position and direction. And we tell this motor controller how do we need to move this beam in order to bring the laser beam back to its target position or target region. Yes. And how this is structured in Tango. So every time we have a pulse, we have a trigger, and this trigger is sent to the first Tango device, which is our camera. It is only there to communicate with the camera to take the picture, and the picture is then given to the next Tango device, the image cleaner, where we do some background subtraction, some different stuff to make the position calculation more reliable. And yeah, there are multiple different things like thresholding also. And then we give this cleaned image to the image calculator, which is again a new device, and where we calculate the beam position where we could use different methods like center of mass. And if we do this for both pictures, for the far field and the near field, and when you have those two positions, we have again another individual device which only takes those two positions. For example, it averages over multiple images, around 10, and to account for noise in the beam movement. And if we then, if all safety checks are okay, then we actually calculate the needed correction movement. And this correction movement is then sent to the motor controller device, which communicates only with the controller and is just there to move the motorized mirrors. And of course, this is not only done once, but in an infinite loop to always actively counter this beam drift. And for example, here we see such a beam drift. Here on the x-axis, we just see the time over 1 hour. And in gray, or on the y-axis first, we see the beam position x and y direction. In gray, we see the expected uncorrected movement. So we actually see how the beam more and more deviates from its target position here in the middle to somewhere here below or above. And now every time the beam leaves this target region here with the gray dotted horizontal line, we perform such a movement to move it back to its target position at 0, and therefore we keep the deviation of the beam's position from its target position relatively small. And just to mention, here the target region is over-exaggerated just to make it more visible. Normally it's in the range of the noise you see there in green. Yes. And how we handle all this, of course, first, right now we have 8 of these stations planned. 4 are built right now, here 1, 2, and 3, and 4. And right now 3 are in daily use so far. Every time we turn on a laser, we actually already use the auto-alignment system, but also the drift stabilization just while we run the experiments. And our next goal is just to build more stations. All these 8 stations are planned. And this already helps us to reduce the turn-on times from 2 to 3 hours by actually 1 hour. So it makes it a lot more easier, or at least time efficient, to start up the laser every time. Yes. And because we have so many of these, or will have so many of the stabilization stages for the laser, but also all the different individual research groups, which all need different GUIs and have different tools they need to work on, and which can get quite confusing. We built our own Tango launcher with Taurus, and here we just we just create a very simple overview over all the different possible GUIs you could have for these experiments, and we separate these. For example, we have the motor control panel or the image panel here for the cameras. or the motor control panel we just open by clicking on the symbol, on the logo there. And we actually just switch the Tango host where we have, as I mentioned, one for the individual research groups and one for the laser. We can switch very easily here on top. And then we have an individual Tango launcher for these, an individual widget for all these research groups here. And this actually makes us possible to have a very specific GUI overview for the individual research groups, but still have a clear separation between them to just make it easier to manage. Yes. And there we can also see the stabilization system. So here in the Atlas panel for the Atlas host for the laser, and we actually see we have two for the stabilization. We have one so-called expert panel here on the left, and here in this panel we essentially have all the possible features and settings you want. It is mainly used for maintenance, and for daily use we use the multiple here on the right, where we can see the multiple stabilization stages here on once, where we don't show all the features and settings, only the ones you actually need to use it in daily operation to make it easier. And yes. And another thing we also have here in the Atlas panel is the Thales panel here on the top right, and here we just want to have an overview over our amplification lasers. For example, here we see for every stage we see the energy, we see the spectrum, and we see the laser beam profile for all the different stages in one tab, and we see in another tab the current state of these machines if they are turned on. Instead of having one individual window for all of them, we have a simple overview. What is turned on, what is the state, and yes. So as a summary, we are student-run. We host with the students the Atlas 3000 laser, and the Python and Python environment we use is run by those students and also developed. We built our own active laser stabilization to counter the beam drift and to save us time for the beam alignment. And this can be up to 1 hour we save. And to handle all this and to have a great overview, we built our custom Tango launcher, which essentially unifies the GUIs for all the different research groups, but gives us the possibility to have a clear separation between them, which actually makes it a lot easier for the research groups. Yes. Thank you a lot for listening. Thank you for also the people at CALA who did all this, and thank you to Deutsche Forschungsgesellschaft who funded this work. And as always, a lot of our devices and projects are actually published on our public GitLab. So if you want to check it out, or maybe you think you could find some useful devices, would be very cool. Yes.
Well, thanks, Sebastian. Now it's time for questions. So we have time for some. No? Okay, well, I have a question. That it's in the case of this drift alignment correction, what is the response time, actually, of your system? Once, when it detects that the laser has drift,
yes,
how much it takes to realign?
So we do when we see it's out of this target region, and then before the next shot, always 1 second, we do the correction movement.
Mm-hmm.
Yeah.
You do it for all the mirrors?
There are in between. There are some stabilization stages. So not for all the mirrors, but between all those mirrors, we build some stabilization stages. Mm-hmm. Okay. Always 2 mirrors. Yes.
Thanks, Sebastian. There are any more questions?
Me. I have one question regarding the widget for the image. You use Taurus widget for this, or
For the image,
in the Qt application? Yeah, you use Taurus, I saw.
yes.
And for you use Taurus image widget, or you use maybe PyQt graph or some other library directly? What?
You mean for the graph? I think we use, I'm not quite sure, I didn't build this myself. I think we use just a PyQt graph.
Okay. Okay, thank you.
Well, let's thank the speaker again. Now, the next presentation, it's, correct me if I'm wrong, it's also from CALA, and it's will be presented by Mykhailo Salan. The title of the presentation is Operation of a Liquid Leaf Target System for Laser-Driven Ion Acceleration using Tango Controls.
Can you hear me? Right. My name is Mykhailo Salan, and just like the previous speaker, I'm a student assistant at the Center for Advanced Laser Applications at Garching near Munich, Germany. The topic of my talk is operation of a liquid leaf target system for laser-driven ion acceleration using Tango Controls. Now, in this talk, I'll briefly introduce you to our research field, which is laser-driven ion acceleration. I'll tell you about our experimental setup, about our target system, and about two of our ongoing projects. Now, as Sebastian already told you, CALA is a research center located here in Germany. Here you see the picture of a beautiful laser facility. And this whole center is built around this Atlas 3000 laser system, which operates at 1 Hertz. And what we do with this super powerful laser is laser ion acceleration. Now, what is it? It's a new type of particle acceleration. Now, comparing it to conventional accelerators, you don't need to build a super big and expensive, say, synchrotron. You just need to build a super big and expensive laser. And what you do is you shoot this laser at some target, which could be a gas, it could be a liquid, it could also be a solid target, say a metal sheet. And what happens is when your super powerful laser pulse meets the target, the electromagnetic fields are really strong. They ionize the material, so they create plasma, and they also create acceleration fields so that you have this ion and electron bunch shooting out of the target. And this is exactly what we want to do research on. So in and of itself, it's a quite an interesting physical system, because we have relativistic plasma. We also have relativistic particles coming out of it, and ultra-high peak currents inside. But it's also interesting from the application point of view, because our long-term goal would be to enable more affordable radiobiological experiments in the context of radiotherapy, for example, as well as research in astrophysics. Now, how it looks is something like this. This is our cave. And in this picture, laser comes from down below, gets reflected a few times, and is then focused onto our target system. Now, there acceleration physics happens, and a proton bunch ion bunch shoots out, and we can guide it to wherever we want it with some magnetic optics. Now, our target system is actually the star of this show, somewhat. It's called a liquid leaf, and how it's created is you shoot two water jets at each other, and where they collide, they create this leaf-like structure, which is quite small, only about 1 millimeter in length, and a few micrometers thick. It gets thinner as you get down. And, well, before, you would use usually solid targets for laser ion acceleration, But in science, you want your results to be reproducible. And the problem with metal sheets is if when you shoot targets, when you shoot particles of your target, it's no longer really reproducible. A liquid leaf doesn't have that issue because it regenerates itself. So theoretically, you could do unlimited 1 Hertz ion acceleration if you will be able to have a stable liquid leaf. And this is exactly what we achieve to do. But we have some issues with it. Now I'll explain them to you with this rather crude graph. How we position our liquid leaf is made in this way. We have 2 nozzles. One of them is movable in the horizontal plane, and the whole nozzle system is put on a hexapod. So actually, we can move our liquid leaf in all 6. We can rotate, and we can also move it in 3 dimensions. And we do it to place it around this microscope, which is connected to a white light sensor, which we use to measure thickness, and to several cameras. So we have a system which has a few rights of freedom of movement, and it creates a few issues because one of these nozzle motors that can move does so during laser operation. And because it displaces itself, we need to be able to align it. We do it manually for now, but we would like to do it automated. We can do it with the manufacturer's software, so we need Tango. Another issue is, well, not an issue. We have to measure the liquid leaf target thickness each time when we start operation. We do it manually for now. It takes time. We like to do it automatically, so we need Tango. And for now, we have half of our target system implemented. Our hexapods and our cameras are all integrated, so we need to only integrate our nozzle motors and the white light sensor. And these are 2 of our ongoing projects. Now, I'll tell you about our white light sensor, which we use for thickness measurements. It's a confocal DT2451 micro epsilon controller, but we misuse it. We only need a spectrometer and an LED from it. And we measured the thickness using a technique called thin film interference. Now you can come across this physical effect. For example, when you look at a water mixed diesel thin film, these beautiful, colorful rings. And they come about because when you have, say, a light source like our sun, it has all these different wavelengths of light. And depending on the wavelength, when you meet a thin film, some colors will become stronger, some will become weaker. And in the end, you'll have an interference pattern, somewhat like on this. And in the thicknesses that we operate in, it's basically a fingerprint of thickness. So if we know our LED that we shine onto our target, we also know the reflected signal, we basically can determine the thickness by fitting a model that basically simulates this thin film interference. And that's exactly what we do. Here you can see in blue the signal that we get, in orange our fit, and it's more or less quite good. Now, to make it a bit more understandable, when we take all of these measurements at different points of our target, we can make this sort of graph, and you can see that it has this sort of inverse proportionality because that leaf gets thinner as you go down. So right now, we use this thin film interference in 2 ways. First, we shine automatic LED at our target, and we get these stripes. Now, each stripe basically represents an area of the same thickness. So if you go along one stripe, it basically has the same thickness. And what we can use it for, we can choose points at which we want to measure thickness, right? Like if you go over all stripes, we'll have a good thickness profile. And afterwards, we can measure the thickness at each of those points to get a good thickness profile. And right now, we do it manually. We drive over all of those stripes. Well, not all, some, about 10 to 20 times. And we get our thickness profile. We can make it automated with Tango pretty easily, we think. So it's a project that is in production right now. Another project of ours is nozzle motors. And as I told you, we needed to automate nozzle alignment during laser operation. And what our setup is, we have a Smaragd motor controller and Smaragd motors. For now, we have to align the leaf manually after we detect a displacement, but we want to do it automatically in the future. So our Tango structure for our nozzle motors looks somewhat like this. We have separate just Python controller classes, as well as controller and motor classes. So we just have clean Tango classes in the end, because our Python classes handle all communication with hardware. And what we basically do right now manually and want to do automatically is we shoot at our target with another laser, not the powerful one, and we look at its reflection on some screen. Now, if our leaf rotates, the reflection rotates as well. So we can actually detect when our leaf undergoes displacement. And right now, we have to do the autocorrection. Right? So, like I said, right now we want to achieve automatic liquid leaf alignment. We do it manually right now, but it's time-consuming and prone to human error. So our goal would be to achieve a closed-loop stabilization of liquid leaf rotation. And right now we are close to implementing the Tango device, and the next step would be to actually automate it. So in summary, we have a half of our target system already implemented, and we have 2 ongoing projects that are right now in testing. So the next stage would actually be the automation. And of course, the end goal would be to have unhindered 1 Hz laser ion acceleration in the end. Now, I'd like to thank all the people at CALA who do this, and also the Deutsche Forschungsgemeinschaft for funding this work. As Sebastian said, you can find many of our projects publicly available at our GitLab, and we also plan to make the white light sensor and the nozzle motors available there as well when we're done with testing. And yeah, thanks for your attention. If you have any questions, I'd be happy to try and answer them.
Well, many thanks for both presentations, because both have been very good, and we are quite ahead on a schedule. So we have time for questions. Well, I have some questions, because actually, as you had in both presentations, there are several motor controllers involved. You plan to develop your own motor controlling, or to reuse some of the existing ones in Tango?
Well, we use an existing motor controller from Smaragd, but we write our own device for it. So
Okay.
actually develop it ourselves, yes.
And there's no other questions? No? Well, I had one that it's for you and also for Sebastian. Maybe how it is the experience to, as a student, to start with programming with Tango and knowing all the Tango control system as part of your PhD?
Well, not exactly PhD yet, but actually it's quite good. I mean, we get a lot of help, and I think Tango has become much more accessible right now. So I'd say it's quite all right if we get it somehow done.
We have a question here.
What would you say are the pain points in using Tango? Like where do you struggle regularly or sometimes?
The pain points. I wouldn't say that there are some actual pain points. Well, the only thing is we use Pogo, and sometimes that can be a pain.
You're using Pogo for the Python device servers?
Yes, we use them for just a general structure when generating a class, but...
Okay, but you know about high-level API and things?
Yes, Okay. So.
Okay, so there was no questions 10 minutes ago, eh?
No, well, thank you very much. It was very interesting. But while I was listening to you, I was thinking that you have a lot of sequences going on here. Yeah. So you have the Tango devices, and you do some automation around that. How you do that? Is just a program you're using Tango as a client, or?
Well, for now, automation is still mostly planned. We plan to use, well, our Tango devices for it, but first we need to build them, and this is what is the current progress is that we actually build the devices and we are testing them. So automation will come right afterwards.
How much of AI coding have you used?
Actually, probably almost zero.
One question for sequence or for scans. Do you consider to use Sardana?
No, we don't use Sardana at our facility for now. I believe for infrastructural reasons, but I'm not an expert. Florian is in line.
Yeah, yeah. So like I considered using the Sardana. I did not. Do you hear me? Yeah. Okay. So I considered using Sardana a while ago, but I did not find the time yet to really like dive into and establish it at our facility. But I'm very tuned to look at the workshop now. So maybe in future. Thank you.
One more. Obviously, you're using desktop front ends, GUIs, right? Have you ever considered using web-based front ends for user interaction?
Well, we have manufacturer-made web applications, but for our use, we believe that desktop would actually be probably easier. I think we could think about this in the future, but right now we just use desktop applications.
Yeah, so we actually used in the past, so like Taranta and also like some Python stuff. But in general, it's very hard for us to maintain because we are just PhD students and not like real IT experts. So yeah, we are used to program in Python, and so in web-based stuff, this is usually hard to build reliable, I would say.
Right. So thanks again.
Let's thank the speakers again. You will use the laptop? No. So the next speaker is Alexander Kessler. Let's check which microphone we can use. What do you prefer? You have this. It's on.
Oh. 1, 2, 3. Раз, два, три. Yeah. Yeah. Both and video too. Was?
So the next talk will be HIJ-pyVision, GenICam camera device server with expandable analysis library and user interface for laser labs by Alexander Kessler.
Okay, yes. Yeah, thank you very much for introduction. I enjoy really this workshop, despite I have really much unluck wearing travel and today with my computer, but due to great support, I have solved my problem. But the presentation is not perfect. I excuse for this. So I introduced HIJ-pyVision in my first talk already. And now I'll go a little bit in detail, and I decided to change my structure of presentation because you are everybody almost expert of pyVision, and you can look inside, and you can use also this guy with teammate to analyze the code. And I want to present my experience with refactoring of the code I get from Student Innovation. It was a solid base for starting, and so it's a solid base for cloud code, because what Thomas said day ago, the AI assistance is so good as people use it. So our goal was to develop just one most universal device source for cameras, and we go to the GenICam interface. Basically, GenICam interface is industry standard for 2D sensors, and is defined by a consortium, European Machine Vision Association. Okay, I think I go just through the architecture. So our motivation, very short, I explained already. We want to go away from LabVIEW because we have some concerns about license politics of national instruments. We want to go more advanced or more state-of-the-art data storage formats. Now today, students prefer Python and not LabVIEW. And most important for laser application in the lab, we need a good replacement for our widget. And this is also, you can see it in code and also from work. It's done mainly by Andrian Justinarski from Stu Innovation and by Wojciech Kitka, and other parts from Michael Hemperek. And as a special, this is really a lot of work. This is quite... So all the features like ROIs and so on, you will see it in my presentation. So component overview, I have one super project called HIJ-pyVision, and here I included a JIT Zoo project, and yeah, we have a camera device server, but this is basically not true. It's just an image source. It can be a file reader. It can be a simulator. So we have an analyzer device server. We have a settings tree for change almost everything what is possible to change via GenICam. And of course we have our Taurus Qt live viewer, and I learned yesterday Taurus went to Qt 6, so the next step will be to update all our stuff to new libraries. So now component I write here, it's 2. Why? Because this diagram is so-called second level C4 component overview, and to the C4 I go to the next slide. And it introduced by a guy called Simon Braun. Does anyone know about C4? Okay, some people hear about this. I would really reduce it. I think almost everyone heard about UML. I use it too, but what I mean I used to, I draw UML diagrams for myself, but if I give it diagrams to somebody else, this is some kind of sketch, nobody will understand this. And this is the experience by Simon Braun. And he developed some kind of C4 approach model. It stands for context, container, components, and core, also 4 times C. So, and you can imagine it is like a map, so like a Google map. So usually first Europe or the world, and you can zoom into the Europe, and you can see to the Barcelona, and you can zoom into the Alba. And in the Alba you can see the streets and so on. And so this is the plan. So first one, this is overview of first level context. So what we have in our playground, what I say, or our situation, we have one operator, we have laser system, we have Sardana, we have our HDD configuration to the bank, we have database, we have HIJ-B++. So this is basically our context. Now in the second level, I go to the container. So this is the overview of container diagram. So, and here our parts are more in the, so basically these components from in this container, these components from my system. So, and yeah, well, how I did generate it? I just used cloud code. I learned about this approach, C4, and I think, okay, maybe what's the problem with agents? The problem is, as Thomas mentioned also, locally, if you have, this is my code, I have some bugs, correct this. Locally, the problem solving is quite good, but the most important part of what's often missing is overview about complete system. And you can use, let's generate this draft of this C4 diagrams by AI agent. You can improve it because basically you get some kind of code, or you can improve it with a tool. This is a plain OML viewer for Visual Code, Visual Studio Code, and you can include this information again to the, for example, CloudMD, to configuration of agent, and say, okay, if you make your decisions, consider please these diagrams. So it's my subjective experience. It's not scientific study, but my experience is it worked quite well. I cannot say it save tokens, but in as results I get from it, for this it was quite nice. And yeah, well, this was the approach. So about designs of, for example, camera device server. It's so well. It sounds really nice as a GTL harvester, so should supports all the cams. But the devil hides in detail. For example, a light vision implementation of GenTL producer ignores the timeouts, and if this happens, your thread is just dead, and you need to, yeah, if it's not if a thread in a device server, you need to start a device server. But if it's a subprocess, you can just kill it, restart the process. Because of this, the communication with Tango device server is done with multiple process queues, and this is nice, really nice side effects from this. We have zero coupling to specifically, because we communicate via messages pattern, and messages are as a command pattern, better way, and the command pattern is yeah, the camera is start, stop, Z, something attributes. So it's completely independent from implementation. So you can replace harvesters by for example, by a simulator or by file reader. So this is point one. Basically, it's the same idea like LabVIEW actor framework. If somebody know this actor pattern, it's at one glance familiar. What I really love is Python transition state machine. You can also, it's really easy to use. And imagine you would map this diagram with some kind if else, you will map. And I am quite sure you will not able to manage all transition and all cases. So with P2 transitions, you can define for everything, or some callback functions. So for example, for entering the error state, or for this connection, or some transition, you can for everything define really fine gray, as a really fine structured, well-defined states and code. And yeah, it's use a lot of Python magic, what I not understand, but it's work really well. I really like it, and would like to have something like this in Tango. For example, if your device make a transition from on to standby or whatever, you can just define a callback on is it. So as of in each case, I think idea worth to look at this. So this is interface for our camera implementation for cameras. So we have a basic class, base class for device servers, and all the specific implementation inherits for this. For example, this here is a HDF writer plugin mixin embedded. So because of this, we have a lot of stuff for storing the files. Okay, the feature, as I already explained, as it's vendor neutral, supports a lot of cameras. It's co-works with the GUI, so if you define a ROI mask in the GUI, it also generates a ROI mask image, and the metrics calculate also only this part, not the whole picture, but only the ROI. So we have a storage with in HDF5 files with frames, compressions, and also with information about the ROI and calibration. And we have access to the settings via GenICam, and okay. If you change something, I go some slide back. If you change for example, exposure time, it will be stored in also dynamic but also persistent attribute in Tango, and after a load it will be set to the same. And all the stuff you changed appears here. I think common application will be to set area of interest, because sometimes we have a really small spot and we don't need 2000 times 2000 pixels. We can just set area of interest, and that's it. So here, if I start another child class from this is for simulation. Of course, we get here some attributes for related to laser beam simulator, and here we see also a feature from GUI. If something is wrong, so for example, matrix is not started, the operator see immediately here feedback. So now I want to show you a demo. It's a mouse here. Mouse. Yeah, thank you very much. Okay, it's running. So so first of all, my device server is not running, and because of this, I have here some messages, and I want to simulate a black hole. So I just first I define a base directory and a work directory, because base directory is some kind of path to a server, and work directory is changed from day to day, and so the whole path is combined from this. It's also for Tango integration. So now I have collected my background image, and now I started also subtraction of this. So now I go some simulation of my beam. Okay, now this is a target cross, this is a centroid cross. If rho is not z, the whole image is calculated. Now I can add a dynamic overlay. And one point I have to learn, the people need really change the color. because we have laser glazes and sometimes you just not see red or green or whatever. So you have just to, that's just our experience, and this experience integrated in this solution. It's a little bit to that. So if I jumped around, so now I activate also overlay for this. This is centered overlay. As next, I will define array. Now I say I start saving of the files. You can define how much frames you want to have in the file. Now you can define array. It's also stored in device server and also in the HDF files. Now only the points inside the array are taken into account. Okay, and after I saved some frames, I go to the reader. And file reader. As a file reader inherits also from base class because of this all the data flow is the same. Data source is different, but it passes the same pipeline. So you see which the interface of viewer changed is adapted to the file viewer. You have possibilities to select a file, of course, and to start a playback. Okay, and you see all the information you need to reproduce the results of here. And yeah, it's basically it. Okay, now you see, okay, I have defined array, and so if are some doubt in your results, the scientists can reproduce this. So okay, to save a time, I will stop it. And I am almost finished. Three minutes, wow, so much, okay. So, okay, Matrix device server is designed that way you can add your own evaluations. So for example, here I add energy evaluation. So what you have to do, I have to put one new Python file in the folder of our files, calculation files. I have to inherit a class from my analyze base. I have to define the result fields, and what I get if you start next time matrix.ts. This selection from available classes is adapted to the energy, and also if I select energy, I want to have it in my calculation. This result fields are dynamically created, and you can use it in overlay, or you can use it in Taurus, whatever. You can use these attributes and so. And of course, if you can see here, it's processing latency. If it becomes too slow, we get also on feedback, you lose frames. So it is also visible in the GUI. So that's basically it. Okay, and the future of Taurus widget I show you already in the presentation. I think we can skip it. So here, as I said, is also if something went wrong, you can get feedback. You can here add some static indicators. Yeah, and I have still to adjust context of menus according to the selection of matrix.ts, but it's not a big issue. So, and then summary and next to do. So, okay, I think I show you this vision stack tailored for laser labs, but you can, I think, adapt it to the overlaps. I think the dynamic overlay real-time overlays feature is really nice, and can be used in a lot of areas. This is completely free on open source. This is complete Python. We use PQT graph for drawing. This is stored in fair data format. You can reproduce everything. You can interoperable with this. You can access this by a Nexus viewer or a HIJ-5 viewer. And it's also, I skip it, but it's also integrated with Sandrana because we have developed also Sardana controller with some hooks, checking okay if file okay, and that's our typical workflow. For example, laser shot set XY, write it in the work folder, and if we start Sardana scans, it also starts camera acquisition. Okay, next steps to do a test because well, my possibilities are quite limited, and even for Dominic arise some issues. I think due to some network configuration. So the 2-bit package mode supports harvesters not out of the box, but we have also one solution for this. So just must be down. And another point is the Tango supports the 8-bit and 60-bit arrays. It also big waste of Ethernet bandwidth. I think it's possible to compress images to a byte stream as bytes than to via byte streams. Okay, and now I am finished. I great thanks for Adrian Jastunowski and for Wojciech Kitka, Michael Hemperek, Thomas Madej, and Lukasz for managing the project at the beginning. It was not easy, and well as to innovation team. And thank you for your attention. That is my, that's my electronic monk on Draco supports me for live images.
Let's send the speaker. Well, it has been it's a very impressive project, Alexander. We have 3 minutes for questions. So, are questions in the room? Well, I have 2 questions. You mentioned that it's your companion, it's Claude, when developing.
Yeah.
So, what percentage of the code you would say that is developed by code once you give the diagrams and the context to it?
This is difficult to say, but because the most biggest part was the widget. And it was quite ready. So all the logic for ROIs, and so a big part was to refactor. So because this state machine was not there, and also a change from multi-threading to multiprocessing was done by me, and this was quite a big percent. I would say 60%. But I provided information. And I said, okay, I want to have this and this pattern, and of course I have to review the code and to test it. So it cannot be done. Next step will be to program automatic tests, also by this, because I have equipment. I can switch on power of cameras and so on. That will be the next step. And it's really useful to create and keep up to date readmes and documentation. Of course, you have to check everything. And I learned for myself, you have to slow down because the results come so quick. You have to slow down. You have to keep good rhythm of the walk. So walk 20 minutes, 5 minutes break, cafe. Write down the paper, like in the school, write down what you're done. So, and this is really important to just to have overview about the progress. I think there's some question.
There are some question on the screen.
Yeah.
So I guess.
Florian, hello, Florian.
Yeah. Okay. Hi. Thank you for a nice talk. Yeah, I would have two questions, if I may. So, first of all, I saw this nice simulator. I think it's a Tango device where you can simulate beams somehow. Um, do you have a daily use for it, or is it mainly for testing?
It's for testing.
Okay.
So it was example really to produce something by cloud. It was down, I think, in 1 hour
Yeah.
completely. Yeah.
Okay. Yeah. Thank you.
But you can test for everything because sometimes you don't have. It's especially good for testing of metrics performance. Yeah, metrics performance. Yeah.
Cool. And the center of mass calculation and stuff I saw in your GUI, is it done on a device server or in the GUI itself?
This is so the definition is in the GUI. So this is this down in the GUI, but the device server you cannot see it, but it is no, it's wrong direction. Yeah, here. It's just a little bit hidden. This is hidden. Here is memorize royal string attributes as save JSON files, and if you go to the expert mode, you will see it. But the problem with Jive, we have also work out in this workshop. If you have a long string, it's quite inconvenient to see. Because of this, it is moved to the properties from GenICam. It's stored like in a device property. If you have to remove some for example, if you don't want to have here this part because it's quite special. This is inter-package delay for Ethernet. So you can go in the property and edit just a string for this, and it will be disappear. Or a different way, if you want some special attributes to have, you can also define it in a string by hand, or you just edit attributes in tree widget, setting tree widget. Yeah, that's it.
Okay,
thanks. We are out of time, so maybe you can make the question during the coffee break.
Okay,
now it's time for Lukasz Zytniak from S2 Innovation, and his presentation. Well,
thank you so much. Thank you.
And now the next topic will be a web-based alarm management layer for Tango facilities, from PyAlarm and AlarmHandler to Operator-Centric alarm workflows.
Yes.
By Lukasz Zytniak from S2 Innovation.
Good morning, everyone. I prepared this presentation with the huge help from Thomas, so thank you, Thomas. And before I will go to the point, I would like to start with the small story. I would like to present you the GSI that to give you the scale. That it was founded in 1969. It has over 1,500 employees, and they have like over 1,200 international user community every year. And GSI is a huge facility. They have linear accelerator, heavy iron synchrotron, experimental storage ring, super fragment separator, high power laser, and many more. And actually, what happened on 5th of February at 6 a.m. in the high voltage power supply, there was fire. And at 6:30, the alarm was raised, and the fire brigade in Darmstadt, because the GSI is in Darmstadt, close to Frankfurt, was alarmed. And then in the morning, multi-agent operation were starting. The citizens were warned to close their windows, not to go out from the houses, stay there until further notification were forwarded to them. And fortunately, it was in the very morning, so no one was injured. And then, as you see, there was huge, this is a robot that was actually going there because the fire started in the high voltage power supply, so immediately the temperature was very high and fire started spreading. And what were the consequences? So just to give you also an overview, what I described before is the blue part, so this is the GSI. And what is the red part? This is the facility under construction called FAIR, and actually the FAIR, the commissioning was supposed to start this July, and the planned completion of the whole facility was planned in end of 2027. And the fire started here. So actually, before it could be transported to the fair. So what were the consequences? The Unilac building demolished. Beam disruption in 2026, 2027, they cannot run as planned. And now they are thinking about the mitigation plan. They have a few scenarios how to mitigate this. And the full restoration of the damage of the Unilac can take years. But I was going to talk about the software. But before that, very important, alarm system is not the alarm software. What you need to be aware, that even if you have the best application, it's only an application that can support your process. You need to build the process. Of course, it can support the whole workflow, but you need to define how the alarm should be defined. What should happen after the alarm is triggered, who should handle it, and so on and so on. Of course, there are some standards, for example, EC 62682, that supports that with full. So, for example, the alarm should be meaningful, so no trash, actionable, so okay, then there's an alarm. What next? Then prioritized. So to have the understanding what is the most important, documented, okay, I have some alias, but what does it mean? Maintainable, so what next? And not overwhelming. So you cannot have 100 alarms in your screen. So this is a good standard to go. And here is the ICAMS. So the ICAMS is a supporting software tool. It's not a system, it's a tool. And what is, in this case, if the temperature is rising, so then the system is detecting that, then there is a formula that is calculating, because you can set when there is an alarm, when there is a warning, when there is following the severity. Then there is a backend, and then there is the ICAM, so then the front end that actually the operator can see the alarm. So what the alarm does, it's not only to show the alarms, it is a little bit more. So first, alarm monitoring, so active alarms, inactive, alarm details, filters, and so on and so on. Then the monitoring, search through the tags. Then the history of the alarm. We implemented also the snap, so if you are using snap, you can have it. Then the full operator workflow, so what should be done, who is handling the alarms, and so on and so on. Notification, the phone book, the mail, you can have the SMS gateway, and so on and so on. Plus, there is a data sequencer and composer, so something what is already built in the ICAMs. And then there is also the administration, and it is Docker and Kubernetes friendly with all the stack. It is really now it's convenient to deploy it. So how does it work? So if everything is good, no active alarm. When the alarm is activated, then there is activation. Then the personnel confirms that it is working on the alarm. So then the alarm is confirmed. The problem is hopefully solved, and then the alarm disappears. And from the software point of view, the front end is with the React. The backend is done in Flask with the REST API, and then we have also the scheduler. So here you can see, here is in this case it is PyAlarm, but here is the Tango Controls, then plus the web, MongoDB, and then the scheduler. And so why ICAMs? Web-based, user-friendly. There is an API that you can connect. Multi-roles, that it is interesting. It has an Active Directory integration from Max4, from Taranta. And it can be accessed from the browser. So for example, in the Beamnice, this is handy. And what are the advantages? So the Panic, as far as I know, is the only visualization layer that supports Achtung, PyAlarm, and AlarmHandler, all three. Next, it is what is actually the most important from this presentation, that thanks from the SKO, it is available on the BSD license. So if you want, you can have it deployed in your facility, and of course, the SKO can maintain and extend the source code, but we also, as S2 Innovation, we can support you with the deployment or the customization for your needs. So I encourage you to have a look, to check how does it work, and check what is, so what I believe is actually the ICAM is a operational layer, and that it is actually above the major PyAlarm, AlarmHandler, and the Achtung, that can be used in the Tango community or not only as a visualization layer that can be user-friendly and actually fulfilling the whole, providing the whole process for the managing of the software critical alarms. And at the SKO, it was, I think, 1.5 years ago, we did some improvements regarding the latency, and the colleagues from the SKO did the tests, and with the like 100 dummy alarms was nearly instant, 300 the same, only with the 500 alarms it was between 1 and 1.5 second latency of the tested alarm. And at this point, I would like to thank you once again, Thomas, but also Matteo Canzari, Marco, Sonia, and Ugur, who were supporting us with that project. Thank you very much.
Next presentation from Lukasz. Very good news that we have this project available as open source, so thanks to SKA. And now it's time for questions. Oh, we have one. Yeah.
Thanks. I was having a look at ICAMs with Thomas last week as well, and I think, yeah, the front end part and the the having the alarm states and being able to dismiss them, that's going to be really useful. The underlying bit where we're deriving some new bit of state from a collection of attributes, I feel like this has come up like over and over this week in various kind of forums. It kind of really feels like there's something common there that Tango could provide. So I don't know, maybe that's just a question for the room or something to think about, but this thing that's being re-implemented in all sorts of places where we're deriving some new state from some aggregation of other attributes, like I feel like Tango could do something for us there. That'd be cool.
The thing is, actually, in Tango we have many as you have said, we have many implementations of that, the facade, the composer. In the case of, I don't know in the case of AlarmHandler, but in PyAlarm we have some kind of structures of alarms depending on lower level alarms. Yes. So it's the many patterns of the same kind.
There's a discussion and a roadmap talk later. Please raise this. We put it, perhaps, if everybody agrees here in the room, or the majority agrees, we put it on the roadmap.
So in my personal opinion, as we have the Tango group, maybe we could expand the Tango group proxy to device. So any more questions for?
Thank you, Lukasz. Is it mobile friendly? So.
Yes, I mean, depends how big you have the mobile,
Well, just the last question. When you were talking about the notification latency, you are referring to latency communicating to the web application,
yes,
or to the SMS notification
to
system?
the web application.
Okay.
Yeah.
For the SMS notification and on Telegram or whatever, you have re-implemented it, or you are using the?
I think there is at Max 4 for the Achtung there is an implementation for the mobile devices for the Android. Yes, but for the Telegram we didn't test it.
Okay. Yeah. So maybe it's time to develop something for push notification,
yeah,
or something like that. So, well, you're the next speaker. So let's introduce Thomas Juerges. I don't know if you know him. He comes from SKA. And well, thanks, Lukasz. A very nice talk. With the same topic, so we're going to see this next part of the story.
Yeah, I try to be not too boring. Sorry, I need to take a sip of water. We just talked about alarm management, essentially, right? There are many things that can go right in our control systems. Usually they do, but sometimes they don't. So this is what I try to talk about. We have a telescope. We have two telescopes, right? What I want to point out here, the distance between the two telescopes is roughly 9,000 kilometers. That's a flight of, let's say, 8 hours, right? And we try to actually combine these two telescopes to observe potentially the same targets. Usually things go right and everything is hunky-dory, but if we have these two telescopes and we have these many parts, many moving parts, many working parts, things can and will go wrong. And you all know it. You've been there. You've been called at 3 in the morning and somebody said, make it work again. Right, so here's the stage. It happened before our times, Apollo 13. Somebody made a radio call and said, Houston, we've got a problem. Well, first thing that came to my mind when I first heard it, I was like, who the heck is Houston? And the second question I asked myself is actually anybody listening? Somebody's on the radio, somebody makes a call. Is anybody listening? Who do we try to address when we call Houston for help? And how could actually Houston help, if there is a Houston? Well, obviously, there is a Houston. It's fantastic to listen to Houston, but that's not the Houston we need, right? We need a different Houston. Houston is somebody who can actually help us out. It's a first responder. In essence, it's the person who tries to triage the immediate need for a solution. So, usually we call that person an operator, right? And that is where the operator needs a tool, where the tool comes in that the operator needs. It's an alarm management system, essentially, right? Something pops up on the screen, something fundamentally has gone wrong, and what now? The operator triages it with the help of an alarm management system. Right, so we have an abnormal situation, right? Something went wrong. Usually we have then a situation where the operator is like, well, I have the logs and what now? I would rather say the operator should never be in a situation where the operator has to ask the question, what now? No. We have actually the task to give the operator enough information to answer these questions. How is the problem affecting the observation in the realm of SKA? Or how is the problem affecting your operation of the machine or of the beamline? How is the problem affecting the entire system? Is the problem caused by equipment malfunction, or is it a human fault? Can the operational state be recovered? Is human intervention required? Is it really required? Do we really have to call somebody at 3 in the morning? And who is actually the person who really needs to take action? Many questions, right? And so that goes back to the operator. We need to support the operator to answer all these questions, because then the operator can make the right call. First line of support. So, that's a little bit boring. So, we have lots of requirements in SKO for an alarm management system, right? But it boils down to this summary on the right side. We want to be able to have a 1 second delay only between an incident and the operator's notification on the screen. Since we're talking about remote systems, 9,000 kilometers distance, perhaps potentially even more between the HQ in the UK and Australia. So is that accomplishable? Okay, we have to see. But these are the requirements, right? So alarm reporting has to be a thing that just happens, right? The operator is not supposed to check for alarms. The alarms have to pop up on the screen in front of the operator, right? So there is no pull. Alarms need to be push all the time, right? They have to be in a reasonably human-readable form. We can't confuse an operator at 3 in the morning or 4 o'clock in the morning or any unpleasant time of the day with a cryptic def failed exception. Sorry guys, that doesn't cut it. You're holding it wrong. And finally, everything should be as detailed as possible, because the operator is the first line of support, response, right, and is trying to help everybody. Right, so what have we got? We have our requirements. We have the IEC 62682 standard that Lukasz already described. This is actually a way to turn our Tango system and all the information our Tango system provides into actionable things, actionable items, alarms per this standard, alerts, right? So what we have now is a joint mission between whatever your facility has as notifications when things go wrong, right? Requirements. Then we have the standard Then we have ICAMs. This is now where ICAMs comes into play. And that actually turns out to be our SKO alarm management system, but it can also be your alarm management system. I'll get back to that later. This is pretty much a rough design how our system will work, right? It's unfortunately a very bad image because I don't have the real image. I had to copy it from somewhere. So key components are, you know it, the TangoDB, blah, 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 alarm handler device, and so on and so forth. Your Tango devices. The Tango devices are then the source of your information to trigger actions, right? And so, okay, now I have my Tango devices. What gives? So what I can do is I can deploy an alarm handler device or panic, thank you, or Achtung. And these devices can actually, with the help of rules, look at attributes and evaluate their quality factor, their values. If it's a 2D array, an image, at individual items in the image, and use Boolean logic to actually trigger then an alarm on the operator screen. So, all right, we have that now. So now we have given the operator the tool, or our control system, we have given the control system the tool to actually do something. What we also can do is we can now go and have one Tango device that's an alarm handler or panic, PyAlarm or Achtung, and we can chain them. So like here in this rule, right? So we have an attribute value. If the attribute value is 8.4, and in the other alarm handler, there is an alarm that is not acknowledged yet, then trigger another alarm, which means we can actually go and have layers of alarms, alarm aggregation, so that we don't bother our operator with 1,500,000,000 alarms. No, just 3. 3 alarms because they are summary alarms and they actually help us and help the operator then to assess the situation. All right. Scalability, I just mentioned it, right? We can chain these alarm handlers that we have, the Tango devices, because we're essentially just dealing with values of attributes. How hard can it be, right? It's simple. The beauty of this whole system is it's just looking at values of attributes or of their quality factors. Pretty simple, pretty straightforward. These rules, everybody can write these rules, which means our hardware engineers can go and say, look guys, when this actually happens on my FPGA, I think this is the moment when you need to take action. So I can ask the hardware engineer, okay, can you formulate that in a rule? Do you have in your ICD a monitor point that you can show to me where you say, okay, that is the monitor point that my Tango device has to read, where then the value is reached and my operator has to take action. And the hardware engineer will say, yeah, of course I can. Of course, no problem. Bob's your uncle, I have a rule, everything is done. So the whole enchilada actually scales also horizontally. I said vertically now, right? I can chain them. One alarm handler looks at the other from bottom to top, sorry, but also vertically. So I can have now one alarm handler above many others that looks at many other alarm handler Tango devices, at their attributes, like might be here in our CSP, SCP, DISH, SAT, SKLO, somewhere, MCCS, and I can again generate a summary of what is going on. Don't be mistaken, this is not about the health of a system, it's about abnormal conditions. So, what have we done? What we have done is we took ICAMs from our colleagues at S2 Innovation. We threw everything, we took the Electra AlarmHandler implementation, which is in C++, which exactly met our needs with regards to performance and implementation, and ease of, and the power of the rules that they provide after a little bit of nudging. Thank you very much, Electra. And we actually went and added a little bit on top, which we call a configurator, that allows you to upload a list of alarms, because, well, everybody knows that when you're dealing with a GUI, it doesn't scale. You can't. Nobody wants to edit 1,500 alarm rules in a GUI. Seriously, nobody, right? So you need a batch mechanism, so we have that. We call that the configurator. It's actually a web-based tool where you can just click and point to a file, upload it, or you can even use curl to upload the file from the command line if you prefer that. So everything then is packaged into containers. We deploy it with the help of Helm and Kubernetes, and in the end, Bob is your uncle. The conclusion of all this, the blah, 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 what is the beef of this? The conclusion is, if I have an alarm management system that gives my operator real information and is really supporting my operator and is not in my operator's face all the time and is not in my operator's way, but just displays crucial information at crucial times only when needed, then we can actually rescue the mission, rescue the people, Apollo 13, right? Or we can keep our machine going or our telescope operating. Only then, right? So, the combination of smart software, smart rules in our alarms is actually a very important step into making our systems work. I really prepared a demo. Until yesterday, I tried to make it work. I actually tried to make it work until 15 minutes ago. Unfortunately, my system is really broken. I'm a Mac user for that. So I'm really sorry. I don't even have screenshots because my system is not working. So I wanted to demonstrate to you how it's actually working, the beauty of iCams, the rough edges that it still has. But so I give you now the and now. What is? So the alarm management system that we have at SKA is there, right? We have deployed it in our ITF system and at the telescopes in SKA Mid in South Africa. We wanted to ask SKA Low to actually deploy it as well in the upcoming 3-month cycle. We do everything in 3-month cycles. So we're working on that. Hopefully we get then feedback, because to tell you the truth, we're among ourselves. It's a little bit rough around the edges. There are a few inconsistencies, there are few improvements in speed that one could do. There are several things that still need to be done. But we are working on it for the next 3 months. Once we've done that, we hope that we can release iCams as package of alarm management system, SKO's alarm management system, with perhaps even some example charts for Kubernetes to you, to the community, to the collaboration. And we really hope that you then will pick up the slack and do the work for us and improve it. Okay, right. So it's about 3 months. That's my plan. No promises. You know, you make a plan, reality hits the plan, and everything goes wrong. So that's the current idea. We have to see. And with that, I thank you very much. Please, your questions. I was afraid so. Hold on.
Thank you. One very technical question. You mentioned the new alarm event and one slide.
Yeah.
Can you say a bit something about who sends the alarm event and who creates that and who gets that?
Yeah, alarm events are a new thing. We introduced that with CPP Tango 10.0. So it's my initiative, actually. Thank you very much for asking about it. So I said, look, when the then current alarm systems had to subscribe to change events, periodic events, or archive events even, right? And that meant that the client had to do all the filtering, right? So, and if I have now 15 alarm handlers installed on my system, all 15 would have to subscribe to events that they are not interested in. So we pondered the question, can we change that? And the result was, yeah, let's introduce an alarm event. Alarm event is triggered by the quality factor of an attribute. If it's a warning or if it's an alarm, it's automatically sent to the client, and you can, if the client subscribes to it. So that is also a very good idea to have a rule to just subscribe to alarm event, right? You subscribe to the quality factor, warning, alarm, done. And
so the subscriber would be like PyAlarm, would be.
Yeah, exactly. Yeah. So sorry, mind reader. Yes. So the subscriber would just subscribe to the alarm event. It's a real thing. It's like change event, periodic event, archive event, and we have alarm event. So if, for instance, you have a Tango device that just operates fine, and you know that when this attribute value goes out of whack, there's a serious condition, you can just set the min warning, max warning, min alarm, max alarm properties of that attribute. You subscribe then in your alarm handler to the alarm event, and Bob's your uncle, right? You just look at the quality factor, done, no problem.
And PyAlarm then generates new alarm events for ICAMs. Like ICAMs just receives alarm events, or?
No, any event. It can subscribe to change events, anything. Yeah, anything you want.
Why would you want to?
Because there are some Tango devices that are not emitting alarm events yet.
Okay.
Older Tango devices. Yeah, okay. Because we're 25 years backwards compatible, which is great in Tango.
Thank you.
We have a question from Lorenzo. And also, well, the integration with the alarm events is still ongoing for most of the systems.
It's a comment. It's a comment more than a question. Is that in the ideal scenarios, basically, all the alarm stuff should flow through this new alarm event channel. So, in principle, the current implementation for the alarm handler or PyAlarm of that kind of might, at a certain point, switch to this channel only, so not going to subscribe to change event, whatever kind of, but just subscribe to alarm event. And this, supposing that then the source of information, which means the original devices, they do provide the info, so they provide event, which basically means that then someone took care of configuring all the parameters required to generate events. So thresholds, blah, 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 blah.
There's a but.
Yeah.
There's a but. Because not every situation can be encapsulated in my min warning, max warning, min alarm, max alarm values. There are conditions that can't be captured through these thresholds, right?
That's where the current approach with these alarm engines on top of devices are useful, because you then decide that regardless of any threshold you designed in the device, you can set up a different logic. Yep. So it's not a win-win scenario. Yep. We'll have to think about.
And I will have more questions. I don't know if Max4 are using ICAMs also? Not yet. So well, it's also one of the points is that in principle, all three systems, AlarmHandler, PyAlarm, well, Panic PyAlarm, and Achtung, have a common attribute that allows clients to interact with all of them three. There is an alarm summary provided by the alarm calculator, and a user interface can see the three systems as a one.
Finally, Alex. First question.
The question was partly answered by Thomas Braun, so I assume because you need 1 second reaction time, all data change must be pushed actively.
Yes, I'm promoting change events for all our Tango devices, right? Which means when something changes by enough, everything gets notified automatically, right? Whoever subscribes knows.
I think it will be a good point to add this from kind to standard device server implementation and add it to Jive to make it configurable in Jive. Some talks about it. Here in Jive, you know, we have here change event, archive event, and to add also a slide for alarms.
The alarm event is for free, as a matter of fact. We implemented it in such a way that you just subscribe to it. There's no configuration necessary. It's built in. If you have min warning, max warning, min alarm, max alarm set, you can subscribe to the alarm event automatically. It's done for you. That was a very good decision made by Thomas Ives for us, because he said, look, hello? Yeah. Look, guys, why do I need to have a different mechanism to configure the alarm event? It makes no sense. And he's right. He said, look, whenever I push a periodic event or a change event or an archive, I'm not sure about the archive event, periodic event, change event, why not automatically push the alarm event for free? So we implemented it that way. No configuration necessary, just set the attribute properties, min warning, max warning, min alarm, max alarm.
And well, you can push on any special condition you have in the code, then you can push. What it's hard to configure is the refresh period, because in 1 second, dealing with alarm flooding, I mean, you have to have a compromise.
Like I said, to tell you the truth, right, this requirement of 1 second response time, it's actually not a response time, right? Display time, I would refer to it, is kind of an arbitrary value, right? Because if I run it on my laptop, I have 1 second, right? If I run it on this system at the HQ near Manchester in the UK, and I want to be notified within 1 second if something goes wrong at the low telescope in Australia, well, you know, we have like 1 billion VPNs and I don't know what firewalls. It's hard to accomplish that, right? So don't take the 1 second for granted. I think that's a goal we want to reach, but we don't want to be too much over that threshold.
Do you have, in practice situation, somebody in England have to react to situation in South Africa, I assume so?
Yeah, problem obviously is the time zones, right? I don't anticipate that we have operators at the HQ, right? Operators are on site all the time. And we're trying to establish a support model that is following the sun, essentially, right? So wherever somebody is awake, that's the person on call. Yeah, I mean, for our accelerator partners here and friends and colleagues, right, that's not a problem because you're in your building and you can just walk down the hall and ask somebody for help. In our case, it's a little bit more complicated because our software development teams are scattered around the globe, right? Canada and I don't know what, India.
I have a question. Thank you for presentation. It was great. It is a question about the processes, rather. Do you already have some ARM policy which prevents so-called alarms flood? Because you can have very fast, let's say, notification period, 1 second. But if there will be like more than 10 alarms at the same time, the response time will be much longer because operator will not have, will not know what to do.
I was afraid somebody would ask that question. The answer is no. but I know it's coming, and I know the moment we we have a plan, or we have the intention to actually expose this system to our mid-telescope, like very, very, very soon, within the next 3 weeks or so. I know that question will come. Thomas, why are you displaying 15 alarms? If I remember correctly, there is somewhere a guideline for user interaction that says no more than 5 active alarms per screen ever. Well, to tell you the truth, we're going to have like 100,000 because we are overly enthusiastic about the alarm management system, like we are with our EDA, with everything. Oh, it's a great new tool, let's use it. We have to kind of find our way. There's no guideline yet, because I believe in evolving systems, right? So, and helping the users actually use the systems, listening to them, what they need, what they want. If our operators say, well, look, I'm fine with 10 alarms, well, it's going to be 10 alarms, right? It should be configurable somehow during deployment. Maximum number of alarms per screen, 10, right? So, and then we take it from there. So no, there's no hard guideline yet, no real rule.
Okay, we are at the coffee time, but I see it's a hot topic.
People, don't roast me.
So we have, let's give you this one and that one, and be fast, please.
Just a small comment from experience.
Anders.
We had some network issues or systems not working properly, where you then had like all the 50 stations going off, sending alarms. And I can tell you the operators were not happy if you have more than 5 alarms. They immediately say, can we just turn them off?
Yeah, exactly. And to tell you the truth, that's exactly my experience from LOFA times. When the operator is unhappy with something in their front end, they will just find a way to turn it off. Make it invisible. This is the reality, friends and people. This is just how it is, right? So we have to make things work for the operators, with the operators, so that they can have the tools that they need. So that's circling back to you, Wojciech, to your question, right? The number of alarms we're going to display, well, I don't know. Let the operators decide what they're comfortable with.
Okay, let's Thomas Braun ask and go for
Is there a Tango built-in way for reprioritization? Or would you do that in ICAM somehow, like, okay, this device sends the important stuff and the others are not so important?
No, there's no built-in way. It's you actually create that prioritization through the layering of alarm devices, right? So one device looks now at the other device, or is there an alarm attribute? Okay, the alarm attribute is not acknowledged. Okay, now I can become active in the higher layer, and so on and so forth, until you summarize everything at the top. And my idea is to display only the top to the operator and somehow make it possible that then the operator can zoom into the other layers.
Okay, thanks.
As far as I remember, and I think ICAMs use it, both AlarmHandler and PyAlarm provide an alarm summary with the ordering timestamp of the alarms as they have been activated, and also priorities between alarms. So the alarm, warning, error, debug. So, and you can get this summary from the AlarmHandler, from Electra, from Panic, and I guess from Achtung also, and use this summary to really establish the prioritization, because you have you have the priorities and the time of activation, so you can know what has been first.
I forgot about that. Yes, you have priorities for alarms, individual alarms. It's in the standard. Sorry, I totally forgot about that. So I thought about different priorities, as in, okay, do I have to look at it right now and dig in? Like, do I have to find it? Sorry if I'm too boring, Linus.
Thanks, Thomas and also Lukasz, because they have been both complementary, and they are providing a new web alarm management system for the community. So this is great. Yeah. Let's go for coffee.
Hello, everyone. We are about to start. So please take a seat. Okay. Well, that's great. Thanks for being on time. And thanks for joining the last session, I believe, of this meeting. Before we start, I just want to thank all the speakers that we had these 3 days. I think it was great. It's very good to see how vibrant the community still remains, and a lot of work in progress. So very hopeful. And now the last session, we really want to spend it looking at the future. So I think the first presentation that we have is from Yury, and it's about the executive summary for 2026. So let's clap our hands for Yury.
Yeah. Okay, thank you, Marco. I actually will be very short because it's actually... Okay, so this is a executive committee summary for this year till today. I'm Yury Matveev from DAISY, and also member for the executive committee. Is just too short to remind you, or if you don't know who we are, so what is the executive committee right now? So Tango Control consists of 10 members, SRF, Soleil, Electra, INAF, SRAO, SKO, Solaris, Max4, Alba, and DAISY. And each institution has one representative in the executive committee. And also there is a Vincente, our new big boss, who leads us. So this is why there are 2 persons from SRF. So, and yeah, we try to steer the collaboration, how it should develop, where it has to develop. So, last year I presented some, and I'm coordinator for the Tango Executive Committee for this, and for the previous year actually too. So, and last year I reported, so we had several tasks for this year. First, and the biggest one is that we have to renew the collaboration contract. It will be actually the second renewal we are doing for the next 5 years. And the status up for today, it is almost done. 2 institutions has still to sign, and then it will be valid. The bad news here is that we haven't found any new members yet. So it's still 10 institutions. And then, due to we had to renew this collaboration contract, we also had to renew our subcontracts with our subcontractors. That we had to, actually SRF had to call make a new call for tender for our subcontractors for the next 5 years again, and the status up for today, it is almost done too. Tender results are ready, and next week must be approved by the SRF directorate, and then we will sign the final contracts with the collaboration. The third task I promised last year was that we are going to move website to Wagtail and to the forum to Discourse, and this is just done. You probably already saw it. It's a new engine. Site looks pretty much the same. Forum looks much better. So this is done. A bit of details about renewal of the collaboration contract. So the good news here is that we managed to increase our budget a bit. So each partner will contribute 20,000 euro this year. Per year, and then we also manage that it will be 4% increase annually, so we will get more and more money. And the idea up to now is that we plan to spend almost 80% of this money to subcontract the development of Tango Controls to our commercial partner. Bad news is that even with that, we still will get less hours. Because of the inflation of the prices coming from our commercial partners, it will be not it will be almost the same, but like kind of 2% less. So you see, we can potentially count of 1,400 hours with respect to 5,000 hours we got within the last 5 years. Sorry, and this is a result of the selection made by SRF. We will have actually these next 5 years, we will have 4 commercial partners. 3 of them you already know. This is 2 Innovation, Observatory Science, and Byte Physics. All of them state. All of them continue, but now we also will have the 4th company also contribute commercial partner will be Altair. So this is the result of the tender. It was a public tender. Actually, originally was 16 companies were contacted, 7 replied, and out of the 7 we selected 4. Yeah, this is the status. It will be signed up shortly. Everything finished. The second big news I would like to share you is that we again have to move our chat. The underlying reason is that actually Mattermost wanted, and actually Mattermost changed condition for its product, and now they want money, more money, much more money. And Helmholtz was not cheap. They actually did negotiate for, as far as I remember, something like several months, but Mattermost wanted too much. And so this is why this instance of Mattermost we use now, it will be decommissioned. It will be decommissioned in 1 month, so we have no much time to move. And the steering committee decided yesterday that the new chat will be matrix. Actually, don't ask me. Matrix is something complicated. I can't even explain it yet. So it's kind of protocol plus something like that. But what for us is important, it's also there is a chat. It looks and feels almost the same as a Slack, Mattermost, and etc. There is a web version. There are actually more than one application you can use on mobile phone. So the channel is already created. I also recreated all rooms we had in Mattermost. The story is that how to access. Unfortunately, this self-subscription, as we do with the Mattermost, is not working. Some internal reason in Helmholtz that is, again, I don't want to discuss it here, but what is good about Matrix is that if you already have any Matrix account, doesn't matter which one, you already can go in without any problems. So it's open for everybody. But like you need one Matrix account anywhere. So okay, if you already have one, then you just go this channel. This is direct access, or you use this link to redirect. This presentation is published on the site, so you can download and click to the link there. The story is that if you don't use Matrix, didn't use Matrix before, and you want to sign up for the first time, what we did, Daisy, is that we created this so-called virtual organization, which is Tango Controls right now is a virtual organization in a Helmholtz instance, and we can provide you such a Matrix account within this virtual organization which you can use later for Daisy controls, but actually for any whatever Matrix channels you wouldn't want. So there is this nice link. You click there. Then it's still the same SSO, single site, single sign-in option as a Helmholtz with your institutional account, blah, blah, blah. The only thing that you then, instead of like getting immediately to the Tango Control, you will need first to ask for the membership. Then this link will appear for me and for Linus. We are the admins of this virtual organization, and we will have to approve it. So it won't be instant. We will do it once per day. Then at some point, like if you're still not approved, please knock us somehow with Linus. And yeah, so after your account has been approved, it will be created. Then basically you fell into the first scenario. You already have a Matrix account. The story is that like we probably still need to decide when we just like stop and decommission, and when I will archive this Mattermost channel. I don't know. We still made any decision. I will let everybody know in Mattermost channel when it will be done. Because at some point, the idea is that I will just stop, close our channel in Mattermost, and I will archive all messages. We will put this archive somewhere. to be decided where, that if somebody, for whatever reason, needs to read all conversation, it will be accessible, but it still will be fresh start. The messages won't be, so the history of the conversation won't be transferred to Matrix. It's just not feasible. Again, no new fresh start. But yeah, this is, sorry, but like, this is what we have to deal with. Okay, and the last news for today is that the next mid-year meeting will be held in Solaris, Krakow. And yeah, so that's all for today. Thank you.
All right, thank you very much. Yury, questions from the audience to Yury? Yep.
Just a comment regarding the Matrix thing. So there are a lot of open Matrix servers where you can just get an account and then you can just join. So you can do how you like it. You can also request through Helmholtz, but
yeah. So this is like, as I explained, if you already have a one account, whatever you found way how to deal it, you can already go in. Like Marco example did it yesterday just by his own, without any invitation, just appeared like, oh, I'm here. And we are just offering, because we understand that we have to not just say like, goes in Google, search, whatever, blah, blah, blah. We have an option, easy one for you if you want.
Okay, any other question? No, okay. Good. Yury, let me take 1 second. So it's a chairing and coordinating the steering group is a boring job. I can tell you that. And you have to chase people, never answer email, gather them together, get them to agree. And Yury is doing that for more than 1 year now. He's doing an excellent job. I want to just take the opportunity to thank you, Yury, for an excellent job.
You're welcome.
And okay, this leads us to the next presentation. I believe it's Thomas. And he's going to tell us about the interest groups, which should be interesting, I guess.
Yeah, people. That talk is actually not why I'm here. I'm here because of this. We have Tango stickers again. Sergey is cutting them right now. They will be made available any moment to you. So, in other news, perhaps you're aware of us meeting occasionally for certain topics. We refer to that as special interest group meetings, and we always hope that somebody hosts us, right, and invites us, and then everybody travels there, and we try to address certain things. So, the reason is, the question is actually, why do we waste our facilities' money? Well, it always begins with a question, doesn't it? So, originally, the first one was, where is Tango's protocol defined? Right? And we set out to actually really nail down and put down our RCs, the request for comments, following the IETF model, where a group of people agrees on something and then write it down and everybody follows that advice. Right? That's the Tango RFCs. It allows you to implement, implement the Tango protocol in whatever language you please. Yesterday morning, I was shocked to hear that there's now a Rust implementation for Tango. I'm entirely against it, but I welcome it. So that is what the RFCs are for. It ensures that your implementation is actually compatible with the plethora of tools, with the plethora of available implementations, and can interact with it in a seamless way, and it's just working fine. Second one was, well, some users ask, well, look, I have a Tango device, now I want to plot the data. And the question was, well, why don't you use Jupyter? Okay, how do I use Jupyter notebooks with Tango devices? And we had another SIG meeting at the SKO HQ in Joel Bank, demonstrating how to use JupyTango. JupyTango is a fantastic project, right? So if you have a direct need for, plotting something, using something, Tango devices, anything, it's a Jupyter notebook framework that has Tango built in. It even has a couple of widgets built in. It's fantastic. Give it a try. So the outcome was that, yeah, everybody wanted to use it, but nobody's using it. The next one was at Astron, at our friends in the Netherlands. How can we use HIJ more efficiently? And that was a very good workshop. So with lots of talks, lots of presentations, and actually lots of discoveries, what tooling surrounding HIJ is actually available that half of the people didn't know about. Again, that was very great. It was actually facilitating the then following SKO invitation to how are actually you archiving your beamlines, your machines, because we at SKO have no clue how to do it. So we want to copy what you're doing, improve it, and then use that. So later then we had the Tango feature roadmap. So we actually met here in beautiful Barcelona at Alba. Thank you very much, Sergi, for the invitation then. And we tried to nail down a roadmap somewhat for Tango Controls, because until then it didn't exist. So we said, okay, to have a roadmap, well, actually, we need to be able to modify the underlying protocol, which is defined in our IDL, Interface Description Language file. So we got together and we agreed on how to do it and what we want to actually do kind of in the future. I get to that in the roadmap talk following this one. So, and then we met at Max 4. Thanks for the invitation. Because we wanted to address the big elephant in the room. Tango doesn't support encryption yet at its protocol level. And that's a big problem, because there's very likely no facility in the world that will adopt Tango Controls when it doesn't support encryption. That's the reality. I can guarantee that, right? Because everybody makes a big fuss nowadays, cybersecurity and whatnot. If your controls framework doesn't support encryption, it's a no-go. Epix invested, if I remember correctly, $1.4 million into encryption, and they have it already. We don't. So we need to actually catch up soon. Thank you very much to Daisy, who actually are sponsoring this effort this year. So we're getting AA, authentication, authorization, including encryption. Okay, so now what was really going on in the past year since Giulianova, we had 2 SIG meetings addressing what do we actually mean in Tango Controls when we talk about long-term support? What does it really mean? Does it mean we support the random operating system for 5 years, or does it mean Thomas Braun will answer your call at the 3 a.m. right time? What does it mean? So we sat down at Daisy, thank you very much for the invitation, and tried to figure this out and kind of formalize it a bit so that you actually can look it up. You know what is in the box when we talk about long-term support versions of Tango Controls. That was quite good. We also then started another effort at the LTS meeting that we refer to pimpling. I think TB who talked about it on was it Monday or so? Did we? Oh, okay. Doesn't matter. We did. Okay. So, okay, another meeting this year, just recently, was at Max 4. Thank you very much again for the invitation. Because we try to address another elephant in the room. I don't know if you people at your facilities are experiencing it, but our experience with a device server polling loop is to give it a positive spin, it's a mixed experience. So I sat down and I thought, well, can't we, and I asked the question, can't we have a meeting about this, how to improve this thing? Because in essence, the idea is good, right? I have the device server polling loop that automatically reads my attributes or reads my hardware, and I have the values always at the fingertip and can it provide to my clients in a very convenient way. And I don't have to implement any threads in parallel that, and so on and so forth. So we sat down for a week, figured it out, came up with a new model, and that's also part of the roadmap in the next talk, where we need funding or sponsors and the bottom line is the outcomes of these SIG meetings are always really, really good things. So let me show you some details. Long-term support SIG meeting. We partied a lot. Sorry for the bad photo. That was I can't do selfies. That was the best I could. So we had 12 participants, 8 on site, 4 remote. All the major facilities involved in Tango Controls were there. There's the program. And this is what we came up with for your reading pleasure. So in essence, we said, okay, we don't have fixed deadlines for new LTS versions. Why? Because the major releases that we make are defined by their features and not by dates. When the feature is complete, we release it because we want you to adopt it, because you are running operational experiments, which means you're hesitant to deploy kind of point releases, so to say, right? Because well, you have to guarantee to your actually customers that your facility will operate and function for them. Then, like I said, we agreed on the encryption sponsored by DESI, Finnish Open Telemetry. We need sponsors, by the way, for the events. Dynamic attributes on device level, thank you very much. TB implementing that, thank you very much to Alba for sponsoring this. Code maintenance is a thing that we really need to continue with, right? That's what we also identified for LTS versions, meaning we have to get rid of the dead bodies, of the skeletons in our code base. Nobody, I don't know, is any facility here using Notifd? It's a yes-no question. No, Sergi, it's a yes-no question. It's not perhaps. Yeah, so bottom line is we really want to get rid of that code because it's kind of sketchy anyway. And it was never a loved child of the Corba community. So just switch over to just a comment. It's already broken. So thank goodness. All right, deprecate dev pipe. That's in our pipeline. I hope nobody is using dev pipe. Is any ESRF as usual. All right. You need to find a different way so that we can remove this, please. Then we have the refactoring of the API, licensing, file split done, Pimple ongoing. That is, it's actually a small font, but it's a big work. The licensing could be automated somewhat. Thanks again, TB. The file split was a little bit of an unpleasant work. The pimpling is even more unpleasant, but we just have to do it to make the code base more maintainable. UTF-8 support. Oh boy, had we discussions. At some point I said, forget it. Just forget it. Don't do it. Right, so we need RFCs and we need a migration path via the new additions to the IDL and make it more clear, okay, what is supported, where, how, when. And And we need, we need a sponsor for that work, right? So, what else came out of the LTS meeting? Okay, what does it mean? Now, circling back to, do we support any operating system? What about Solaris, right? No, actually, no. So we support a handful of operating systems, that is macOS, Windows, and Linux. And we really nailed down, or we really wrote down, okay, what support level does an OS get? CPP Tango on that OS gets so and so much support in that shape, right? So this is enclosing the then, okay, for LTS, what do we actually provide? Bug fixes, and yes, no, and so on and so forth. Will you receive new features for LTS? Yes, no, and so on and so forth. So most importantly, what an LTS means for you as facilities is we will never put bug fixes in the LTS releases that break ABI or API. Never. That's a guarantee. And we will also never put new features in LTS releases. Right? As much as you ask or you bribe us or whatever you do, the answer is no. A firm no. Not going to happen. Right? So we have different levels of OS support, like I said already, on another outcome. We tried to actually come up with a support window for especially PyTango. That is what we would say how it looks like now. As mentioned earlier, the next LTS for CPP Tango is kind of 2027-ish. Hopefully, we have to see. So you see, there's an overlap of versions, guaranteed. We try to release a new LTS version kind of every 5 years, but like I said earlier, it depends on the feature completeness of that version, right? So 5 years is a estimation. But we guarantee that there will be an overlap, new LTS release, old LTS release of 2 years. We also agreed on that already in Giulianova last year. The question is, can we integrate JTango into this? Can we somehow fold JTango in and make and give our users, our user base, guarantees about their releases? So far, we haven't started the discussion yet. I hope that this actually is a starting point. Just let's start talking. If you want to do this or not, I think it would be nice because that could keep Jive, the tool that nobody needs but everybody uses. That Jive is up to speed at all times with the latest IDL, with the latest features, you know, alarm events, and I don't know what. So it would be nice to just think. All right. More blah blah about OS support, like where if I have CPP Tango on Windows, what does that mean? What support can I get? That's there on that slide, right? I give you 5 more seconds until we continue. All right. Okay, because we also have talked about PyTango LTS versions. What does that mean if you're only focused on PyTango? You see that here. Most importantly, we focus on 2 platforms, 64-bit Intel architecture and 64-bit ARM architecture. That's pretty much it. 32-bit ARM exists, yes, but it's kind of a voluntary support that we provide. Same goes for 32-bit Intel processors. So, and most importantly, we will only publish source distributions to PyPy for the LTS versions, depending on how much workload Benjamin has. Perhaps there are other versions that we are publishing, if you ask nicely. Okay, so in short now, let's switch over. Oh, sorry, Benjamin. Thank you very much to Benjamin for the slides. Appreciate it. Again, we were partying hard, but we were also working hard. 14 participants at Max 4. 2 remote, 12 on site. The program is there. And essentially, in a nutshell, what is actually wrong or good about the device server polling loop, right? We started with that question because are we at SKO holding it wrong? It's always a valid question, right? Am I doing it wrong or not? Innocent question leading to complex discussions and everything else. Well, and another question is, why don't you use change events? Right? If I use change events, I don't need the device server polling. Well, sometimes we get a third-party Tango device from a commercial partner, and they just implemented it that way. And, you know, that's just how it is. So, and if I suddenly find out that my commercial device doesn't cut the cake because it's too slow, it can't sustain certain rates, I have a problem, right? If I can't make it work faster, well, so device server polling loop can be a problem, doesn't have to be. Usually, I suppose for you all, it works well. Like I said earlier, it doesn't really work too well for us in SKO. Let's put it this way. I'm doing it injustice. It works in certain areas well. In other areas at SKO, it doesn't work well. So, the gist of the device server polling loop is, if you're familiar with it, with the internals, is it really relies heavily on exact timing. If the thread that performs the reading of the attributes is not having enough time, and it runs out of time, it will just stop reading certain attributes, and it will do that all over next time around, and all over next time around, which means some attributes are never polled, some will always polled, and you might, without reading the polling status, you will never know. So we were also checking then other use cases, like why in the universe is the polling loop not supporting all commands? Well, it supports only commands that have no parameter, right? So, okay, so we discussed that question, right? Essentially, the polling loop is useful when you have hardware that is slow to read, you know, device has many clients, data can be read from a cache. Then the polling loop is really good to have, but still, things can and will go wrong with a polling loop, right? Because usually you have your operators or your hardware engineers or somebody in between configuring it, and it takes a little bit of work to configure it right. So I would again say, well, why don't you use events, right? So this is how it looks like, right? The current polling loop. We all know Jive. That's how you configure it, right? You go there to the polling, all right, you set it up, set the polling rate, and Bob's your uncle. And then, okay, this is actually what the polling loop does. It calls the read attribute function, right? And the read attribute function can then read an attribute from the cache or directly from the hardware if I instruct it so, or in case of an error, it can first try to read from the cache, read from the device, and then read from the cache. So I can configure that. It's all good and fine. If everything works right, everything works right. But what if things don't work right? And so that is actually why we sat down and tried to identify the main pain points. It's difficult to tune. You have to get the timing of the polling loop right so that when your device does not respond ideally in the exact amount of time that you think it should respond, then your polling loop is very likely out of whack. So then, well, if you get the timing setting wrong, well, that means that, as I said earlier, that some attributes are never read. Then it's actually not fair, which means from the get-go, certain attributes are never read. Because from the get-go, from the start, my polling loop is so wrongly configured that it will never read certain attributes, period. And that since there is no randomization in the list of attributes that the polling loop reads, it will always not read the same attributes, which is, in my perspective, not good at all. Yeah, the cache, if you read cache, Alex, I think you were hit by this, right? If you have the polling loop active and you have the cache strategy chosen, it can happen that you read old data from the cache. So, and also, it's not really following the Unix philosophy. Confine yourself to do one thing and do it right. Currently, it serves it does three jobs. It is putting the data in a cache, does the periodic updates, and actually fetches the data. So, what we said is, look guys, let's split everything up. We fill the cache, one job. We obviously have to be backwards compatible, another job, right? Allow old polling. And let's get the algorithm really straight and good and performing. So 3 different tasks, 3 different jobs. The first one is actually, okay, the elephant in the room, fetching data from our device, from our hardware, from our source, data source somehow, right? And providing it to the Tango device. So how do we do it? I'm sorry for this big diagram and the small print, but essentially here is your data source. Can be hardware, can be software, can be whatever, can be the interwebs, right? And we came up with the idea of a collector. So that's a thing that fetches the data from your kit, hardware, software, and provides it through a mechanism to the Tango device. So that's what you would implement in the future, right? The data collector, right? It's a fetching, really separation concerns, fetching the data from your hardware. Let's say a CCD camera, fetching the data, and then you make a function call, and poof, it lands in the Tango device. What that means is it will end in the attribute cache, right? And from the attribute cache, we then publish automatically the events. No configuration needed anymore. We decided to automatically publish events for you, so no push change event, no push archive event anymore, right? And we also provide the possibility to set the timestamp yourself, to set the quality factor yourself, right? Like in the old days, like now, right? So actually 2 paths. And essentially, when you then have the device server, the normal device server, the Tango device, it just will look at the data cache. It will, attribute cache, right? So whenever a read attribute call is performed, we will read from the cache and not directly from the device, because the separation of concerns is the collector is talking to the device or to the hardware and nothing else ever. That's the new model we came up with. And I can sense 15 million questions and 200 million discussions coming up. Let's take that to the roadmap. Anton actually went and said, okay, to address the second item on the list, Anton came up with, okay, what's the best polling algorithm? So it's an explorer that Anton built. And we went really through many of the possible algorithms, but I don't know if we actually agreed on one. No, exactly. That's why I don't remember. So we didn't agree on one specific algorithm. So we have to hash that out. I think that's on our roadmap to implement. Right. But that's a great tool because it shows you essentially what if and what when. And it really opened our eyes that the naive approach, oh yeah, why don't I do this? And Anton clicked the button and was like, because of that. You can't do it. because then that attribute is never read. So that was quite useful, or very useful. All right, roadmap. So for 10.4, we are looking at list of minor issues, and perhaps we have the scheduler stats command, meaning that we implement. I don't even remember, right? What was it? Oh, yeah, right, Mike. I have only 15 seconds left, I think. Minus 15 seconds.
I think. Hello. I think the idea was to have an admin device command return a string, JSON string, something like that.
Yeah, that was that. And then after 10.4, new polling algorithm, blah, 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 blah. We come now to the rest. Bonus track, we discuss also the device proxy state in its curious shapes, because there are 3 shapes of the state, right? That is the command, that uppercase, lowercase, and then there is an attribute as well. So we try to wrap our heads around it, and well, essentially, well, it is what it is, right? We didn't come to a conclusion, but perhaps you have also stumbled upon this. We find it curious. Perhaps in a future SIG meeting or so, we're going to address this. And another big question in the room was, well, my device proxy is the same process as the device. The timeouts, some of the timeouts don't work. They become infinite, which is also kind of baffling. Didn't have an answer for, no, didn't have an answer for that, but also that's what we discussed. So you see, at the SIG meetings, it's not all party and, you know, going to fancy restaurants. No, we try to do good work for you and improve Tango Controls all the time. Thank you very much. Right. Next one.
Thanks, Thomas. I guess we're heading towards the next presentation, but maybe we have time for one question, if there's anything. I can't see any hands. Okay, don't be shy, but fine. I think the next presentation is the last of the meeting. We got, I don't know who's doing the talking. Is it? Oh, Jitendra, you got a question online.
Oh, yes.
Yeah, short question. Is there any statistics about CPP, Python and Java Tango usage, Tango device server usage across the community? Means like which is being used the most and less used?
So the question is, to what degree we are using Python, C++, or Java across our facilities?
Well, that's a good question. As far as I can tell, Soleil is the major JTango user, right? Jive is the tool that nobody speaks about, but everybody uses. So every facility uses Jive, which is based on JTango. And I would think you agree with me that the majority of facilities uses CPP Tango or PyTango. And JTango occasionally when it suits the need.
It means it is a supportive kind of usage, maximum.
Sorry, come again.
Yeah, it means Java is being used as a supportive tool, like a Jive or that kind of.
No, sorry, I gave the wrong impression. No, JTango is actively used for every aspect of the Tango Controls systems at Soleil, like archiving and Tango devices and everything else. So JTango is a need that we have to have. Does that answer your question, Jitendra?
Yeah, okay, thank you. Yeah, thank you.
Yes, no, perhaps.
Hello, thank you. Yeah.
Okay, thanks a lot.
Thank you very much, Jitendra. And okay, next presentation is the last one for this meeting, and it's really about looking ahead and looking at Tango road maps. We have a bit of time for this, and probably it will involve a bit of interaction. So I think we head into that, but it's going to be somehow. Oh, and we got stickers. Okay, so I don't know who's doing the speaking. Is it Thomas? Is it who's doing the speaking and the talking? Is together? Okay, it's a collaborative effort.
Both at the same time, yes.
Okay.
I'm too confused.
Love it. So thank you very much. So welcome Thomas and Thomas for our last presentation, and can't wait to hear about the Tango roadmap. And yeah, let's give them a big applause of encouragement before they start.
Encouragement.
Because that's a daunting task.
And us two are going to need it, because this whole thing is actually hinging on you. Just 2 slides to warm you up, and then we disappear and you take over. You'll see very soon why. So, in Giulianova, we agreed on somewhat of a roadmap. And we said, I think it was Lorenzo who insisted on the LTS releases, 5 years, 2 years overlap.
A lot of facilities.
Yeah, I tried to point out somebody who's guilty. Really true. I think then we agreed on the encryption, right?
Yes, yeah. So, but the main thing we agreed on in Giulianova is that it's not about like that you say, hey, I want to have this fancy thing and we'll find someone doing it. No. This is unfortunately not how it works. We don't have any people waiting for work. But the idea is that you can come up with ideas, but you need also to sponsor that idea.
And sponsoring means, in new speak, is you become the product owner. In old speak, it means you actually write the RFC, you write the tests, you get it. Oh, hold on. Somebody writes the RFC. Hopefully, the same somebody writes the tests. Hopefully, then somebody gets hired, or that same somebody gets it implemented, and hopefully your facility, because you're sponsoring it, actually is using it, so that we see it in action and everybody can then benefit from it.
Yeah. And the idea is that you're responsible for getting it done, and you either do it yourself or you find someone doing it, or as you want.
Yeah, prime example is the dynamic attributes. My goodness, I'm not compatible with this thing. Where's the point? Oh, goodness me. This is what Byte Physics, thank you very much, implemented for us sponsored by Alba, right? Because there was a direct need, and that is exactly how we want it to be, right? Preparing an RFC change, writing the tests, implement it, use it, Bob's your uncle, and everybody benefits from it. That's our collaboration.
It's still progressing though, but yes. Yeah.
All right, so this is where I pose the questions to you, right? Do we want to continue with this? Because we need sponsors, we need people to actually do it. We need people to say, yes, I want it. Or should we chuck it to the side and say, you know what, don't focus on it any longer. That's for a sunny day. Again, the maintenance that I mentioned before, polling loop, what I just tried to present, right? The new polling algorithm and the data collector. Please, we think it's important. The group at the SIG meeting thought we really should have that for Tango 11.0 to give everybody a choice and have a sane implementation of the device over polling loop.
Yeah, and the data collector, I mean, it's a whole new idea of like how you would write your device servers. Of course, like the old thing will still work.
Yeah.
But this kind of like idea that you say, hey, the client basically reaches to the hardware and then gets something back, that would be only one of the options you have.
Yeah, yeah. So it's a paradigm shift, essentially, right? From the device providing the data, what we will have then to compare to earlier. Open telemetry events, right? Somebody has to implement that. DevDict.
Sponsor. What about sponsor?
Sorry.
Yes, of course, we need implementers as well.
We need a sponsor. Yeah. DevDict, my favorite thing, agreed at the IDL V6 meeting here in Barcelona. Why can't we have multiple parameters in a command? Would come very handy.
Or in an array.
Or in an array. Right, that's that command, but the command, we said then, okay, how do we encapsulate that without actually blowing everything up? We came up with the idea of a new Tango type called the DevDict. It's a dictionary, key, value, and that should enable us actually to have multiple parameters. So it would look to you as if you had multiple parameters in your command calls, but under the hood it would be just one Tango type encapsulating all the multiple parameters. So also sponsor needed. I thought that SKO would sponsor that, but Thomas Braun corrected me. No, sorry, Thomas Ives corrected me and said, no, we didn't agree on this yet. So we need a sponsor for this. Multi-dimensional arrays. I know you facilities don't need more than 2 dimensions. I understand that. But they could come handy, the 5-dimensional arrays, the 17-dimensional arrays. From the experience at Astron with LOFA 2.0, we could have used 7-dimensional arrays. And now we had to fold everything into, I don't remember, 2 or 1-dimensional arrays, right? Which is kind of, I mean, why, right? I mean, come on. So that, and again, yeah, clean up. Right, so this is it. Drops the mic. There you go. Let's start the discussion. What do you want? What do you want on the road to be on the roadmap for at least 1 year? What should we target? What should we address? And JTango, can we put it on the roadmap? Yeah. Start the discussion, people. We have microphones here everywhere. We can use mine as well. I stop talking.
And I think the idea is that we have like the big picture things like for major versions. I mean, we're always doing bug fixes and we're always happy for every bug report.
Exactly.
But let's focus on like the big.
Right. So, please, the floor is yours. Do we have a need for a certain feature that you're really missing? Right. Alex, of course. And I need to start taking notes. So can somebody, Hannes, can you roam that microphone? I need to take notes.
Yeah, this is a fairly minor thing, but just having other attribute types be able to support alarms like booleans would be great. We kind of re-implement that in a lot of places. Maybe dev enums as well. Yeah.
Yeah, so that's small stuff. If there is no issue, please make that issue, and we'll try to get that implemented. Nothing else missing? Is it perfect already?
Alex, you got some more? Yeah.
Let's have lunch then.
On the polling, I think the problems that you've identified are like dead right from what I have seen. But I guess, yeah, I've got some questions about the implementation, the data collector. What I really like at the moment that effectively the Tango device is the data collector. You define your attributes, you define how to read the things from hardware, and then in the background, in an ideal world, the Polar kind of manages the execution of those commands. I think that's good. And our experience, I think, in SKAO, where we have this component manager that sits inside, it kind of becomes a bit of a mess. And I think there's probably a risk of that happening. The responsibilities of these different components become a bit unclear.
Yep.
So I just wonder, how, how much like in flux are the kind of decisions about the API at this point?
API, we're not even there yet.
Yeah, okay. I mean, just the general design. 'Cause
Yeah,
I think
yeah,
the
yeah.
problems
So
are exactly right.
That is
there's
exactly.
a lot of scope for.
We have the idea. We kind of agreed on that general design. API, we haven't decided on yet. That would be part of the RFC discussion.
Yeah, I mean, just keeping on your comment. I mean, the idea is exactly this one. I mean, the current design, the Tango device is the collector, and this belongs to 25 years ago, 30 years ago, where the approach was perfectly suitable. And nowadays it's short cover, so you pull and you get the feet and the knees, and maybe it's getting even shorter. So we need such a different approach where you can decouple things and look forward to event-driven architecture, basically.
That's
totally event-driven architecture. But the main point here, if you can switch back to the previous slide, the main point here is that I think we got back one more. Yes.
Or was it the previous presentation?
Maybe. So it's basically, my comment was, I think we already tried to put enough things to do on the table. So the main point is finding out sponsor rather than work to do.
Yeah, exactly. It's like, I mean, yeah. So we have presented some ideas, also like the new data collector and the new polling, for which at the SIG meeting we thought, yes, that's a good idea. Let's find someone sponsoring that. But yeah, so yeah, if you, I mean, like.
Yeah, it's really like, people, please, if you have a burning need for something, this is the time to speak up. Alessio.
A couple of stupid requests. And I'm such a fan of Rust and Zig languages. So do you have ever considered to revive C binding to let other type of languages to use for Tango? And the second question is, I would like to see TangoDB distributed across every machine and synchronized with Paxos or Raft algorithm.
Say that again. TangoDB.
Yeah, but
like federated.
Yeah, federated and synchronized with Paxos or better Raft algorithm.
Hold on, where's Mauricio? Mauricio, did you hear that? Federation of TangoDBs. I know that Mauricio has an opinion. That's why I'm sorry I have to put you on the spot here.
So I think it is something that could be done, but probably at SKO I'm not sure if we have issues because we don't have that.
Yeah. Is there a good use case, Alessio? It's a roadmap, right? Because that means somebody has to pay money, invest time, develop resources.
Can you explain what you mean with federation? Is it like you want to like have like it replicated or?
This is Alessio's idea, so merit goes to Alessio. The idea is to have it federated, which means that you can run a number of DBs, is distributed, and you get the information, using whatever kind of heuristics and metrics. So it's basically can be something similar to what's called it? Sorry? No, it's not. It's more than load balancing. Is those Alessio, help me. What's the download tool? Come on.
Oh, it's inspired by torrent. BitTorrent.
By what?
Yeah.
A BitTorrent.
BitTorrent.
You get information from the TangoDB from the nearest plate, which sits where the client, the server is asking for, and is automatically high availability, load balancing, one node disappears, no matter, someone else replies, etc.
Okay, so...
So it would actually be like a new way of using the multi-host feature in Tango, which is not very much advertised.
Yeah. Would you want federated databases, database backends as well? I mean, because otherwise we have already that multi...
I think the multi-host thing is only if the first cannot be reached. So it's not. It's a failure thing, not a federation.
Okay,
thing.
so in essence, nearest neighbor replies to your request, TangoDB wise, and fetches the data from wherever, right? That's a different problem. So we have real parallelism in our distribution of TangoDBs. Is that the request?
And what is the difference to load balancing? I'm not getting that.
Distributed nearest neighbor, high availability, load balancing. Okay.
It's load balancing means that you have a couple of systems, 2, 3, 4, whatever kind of, which sit there with usually a front end, which is dispatching the work, etc. Is not that different, except that it's not a fixed architecture. So, in principle, you don't know with the torrent approach, etc. You don't know which is going to answer. You have a map, and based on the map, you send out your request, and someone will answer. And usually is the nearest provider sitting within. It's not that different.
It is, because suddenly I don't know which Tango host to set.
Well, so
the Tango host becomes a non-thing, right? Because if it's nearest neighbor algorithm, somehow we have automatic discovery suddenly involved, right? Where is my TangoDB? The device server asks, and the TangoDB somehow magically replies, "Hey, it's me." Okay, perhaps. Yeah.
Thomas and Lorenzo and I think that's super interesting.
I'll stop then. It's an idea there, but if you ask me what would you vote for? No, please. Let's have this polling thing, etc., refactoring in place, and we think about this stuff.
Okay, thank you. I think that's great. Probably these 10 minutes that we have now, it's not ideal to go deep in the details of every feature. There's Dimitri here had another request.
Small comment for the previous one. We solved this high availability issue with archiving, so maybe we can have a look at how Postgres cluster work with all this virtual IP address and virtual host. So yeah, you have one host name and you have internally multiple databases that reply to your requests. So yeah. Another topic about this distributed system. We had applied security patches to our Linux systems recently, and we restarted all the hosts in the system. And did we think about the starter for the hosts? So we had starter for the devices on the same host, but because it's many hosts in our system for accelerator, we have devices depending on each other on different hosts, so they were started not in the wrong way, in the wrong order, because of the they run on different hosts, and we had some issues that we had to manually fix after that. So do we think maybe
a synchronization mechanism
for the hosts, for different hosts?
Essentially, a very, very, very lightweight Kubernetes solution. where I can define dependencies, right?
Yeah.
Okay, yeah, why not? We can.
But just a comment. This problem is already solved in latest Astor, isn't it? No? Yeah? Well, okay, if you reboot, but I mean, if you start from Astor, you get the right run levels, but not if you reboot. Okay. Okay.
Well, you get it only on your host, not on when you have a dependency from a device server on a different host.
When you reboot Astor by branches, devices are restarted host by host following the run levels order.
Yes,
When
but
you
if you're dependent on a host which is in a different branch, then you get some trouble.
Of course, if the hosts are in different system branches, then are not related. Well, anyway, it's an obscure system in just a Java application that maybe we could move to the API somehow. So we don't have to go to the Astor application to manage that. We can use it from script tools like Fandango or the takeoff that was shown by Max for the other day. It can be used at system level. Now all these run levels, we have the sub-devices property that tracks the dependencies between devices. Yeah. And we are not using it. So it's something that we could integrate somehow to enable this startup by dependencies. I had 2 points. One of them was that actually there is an ongoing RFC that it's is passing to the clients in the device info flags telling the clients which attribute events are being pushed by a device. So from the device info, you know if a device is pushing change event from code or not, is pushing archive event from code or not. My proposal, and I would like to know if more people is interested in that, is having it in the other way. Actually, we have devices that push change event, and to push alarm event and archive event from code, we have to go through all the code of all the devices and modify them. We would be interested on having flags in the Tango database that can tell, okay, if you push from code, read this flag and push whatever is configured in the Tango database. So just have a push event from code method, and then or push event by flags, and then it checks the database, see which is the current event configuration, and pushes. Because actually, I think for some people it's misleading that a device is pushing custom events, they change the configuration and jive, and it doesn't matter, because the device is doing a completely different thing. So I think it could be good if the flag systems works in both ways.
Sorry, go ahead.
No, that's it.
Would that not entail that events should actually be pushed automatically by the Tango framework instead of having to push them ourselves from the device?
Well, the thing, you always have custom situations in which you push something from the device because of an internal thread, callback, or whatever, internal condition. But be aware of the flags. I mean, actually, our devices just push change. We may want to push alarm. We may want to push archive without modifying the code. That's my proposal.
So that would be a feature, the definition of event publishing through TangoDB per device.
There's a hand raised at the bottom as well.
Sorry?
Come again? A note about starter. We could implement an approach like socket activation, so and discard completely level, for example, and let the system order the boot decide the right boot order itself alone, without any instruction, because it reconstruct the order in base of available of the socket. I mean the socket of device proxy, Unix or TCP, whatever it uses.
Okay, but that's already implementation level.
Okay.
Sorry, Alessio.
But it solves the problem between...
Yes, yes.
Yeah, I think this idea of having attributes defined in terms of other attributes and transformations of those attributes and that kind of thing, I think that would be a good thing to have on the roadmap. What we were speaking about before.
Yeah. So come again. The event-related information, is that what you're referring to?
So at the moment we have forwarded attributes, right?
Yeah.
So you can take one attribute from another device and
Yeah.
present that. I think that extending that concept so that we can have attributes that are defined as some transformation of one or more other attributes.
I see.
Is something that is being re-implemented all over the place. And
like an aggregation attribute type. Like I can specify 15 other attributes. They're aggregated through somewhat of a rule.
Yeah,
I see.
Yeah, that kind of thing. Yep.
Okay.
But I mean, we do have that with facade device and like some other stuff, but
Yeah, attribute composer, device server as well.
Perhaps it exists already.
I think the point is to choose one of the solutions, the most performant, and just recommend it that, okay, you want a composer or a facade, use that one, because it's the one that works. I mean, to choose one as the recommended tool.
Yeah, if I understand that correctly, that is then a specific Tango device that serves that purpose, right? If I'm not mistaken, Alex is asking for, can I have in my normal Tango device, an attribute that is composed of other attributes? So no special extra Tango device elsewhere, no facade, no nothing, no composer device, but this new attribute, type is the wrong word, this new attribute behavior. I think that's what you meant. Okay. Yeah. I think I got you. So attribute aggregation at the level of a single attribute. Okay.
we can have a look what Epix does with the record DB thing, because you can do something like that there. It's
by all means, So we can put it, like I said, we put it on the roadmap. We summarize everything at the end of this session, and that's going to be it. But
as usual, without sponsors, nothing gets done.
Nothing gets done. Yeah.
It's just how reality, because we have a lot of bug fixes and things like that to do.
Sponsored by Alba. It got done. Sponsor needed, didn't get done. There you go. So if you have a need, you touched it last, we want you to sponsor it. Now, anything else? Any more ideas? Please come forward. Brainstorming. The C bindings, yeah.
Yeah, just Alicia's second part of this question, the C bindings. Any appetite to get that onto the latest device versions? Because it's several behind. Well, it's basically not usable. It's way behind at the moment.
Well, the question is, okay, so who has ever used the C binding?
We used it at the ESRF for quite a while, but this with a spec, and now that's gone. We don't need it anymore at the ESRF.
Damien?
Yeah, just a comment maybe on the C binding. Actually, maybe now it's out of date, but with the work we're doing with pimpling and stuff like this, maybe it's not so much work to do it after this. So we'll see. But as well, I'd like to think as well about. I mean, tomorrow we'll do the same work for HIJ-pyVision, try to come up with a roadmap, and I would think it would be interesting to think about better integration of HIJ-pyVision in Tango. We are talking about the history for properties. So maybe we want to store properties in HDB and do not store them in Tango database anymore. So we would have infinite history for properties through HIJ-pyVision, something as opt-in. I'm thinking as well to use for memorized attributes. They are stored in the Tango database now. If you have like attributes that you use a lot and they are memorized, it's a load for the Tango database. It wouldn't be a load on HIJ-. And so maybe it's a way we can, there are some stuff to work there.
Yeah. Let's make Tango database smaller, yes.
So, and support PostgreSQL in Tango database.
So essentially, HIJ++ serves as storage for properties, and what was the second part?
For memorized attributes.
Memorized attributes, thank you.
And the PostgreSQL backend for Tango database.
Well, we have that proposal already. We have already defined it in as work packages, right?
We have a sponsor, yes.
No, we don't have a sponsor. Well,
Damiet did most of the work already, so basically we have a sponsor. So.
Numerous attributes. I wonder if we could put this. Sergi, can you help me put this on the screen, the slide that I'm editing now? Can I just pull the cable out of this thing?
You
or something?
take notes, but just a quick comment on this last. I think I do not like it. It's breaking the separation of concerns. So I mean, one is Tango database is runtime configuration. HIJ+ is historical stuff. I won't mix those two things. My 2 cents.
From a Tango database maintainer point of view, I would think that you want to split out from Tango database the telephone book thing with finding devices and the storage of properties. These are like 2 separate things which don't belong in the same device server. And because of like also for scalability reasons.
Okay, but still it's the same backend.
Yes. Yeah, well, I don't, that's when your thing, but yeah. But
maybe, I would say, no? I think the Tango database, to me, is a scalability issue looking forward. So I very much agree with you, Thomas. I think when we reasoned about the RFC 3 years ago, it's clear, no? The Tango database conflates several concerns into one bottleneck for the entire system. That's a problem for scalability and a single point of failure.
And it was convenient to extend. Yeah, we see it. Yeah, that's good enough. PostgreSQL backend for Tango database, you have that? Yeah. Can we make the attribute aggregation and transformation? Because I think that's the idea that you can like say, okay, yeah. Yeah, I think that's. Okay. Any more ideas or like people jumping up and saying, hey, yeah, I'm sponsoring this right now?
I put actually the names next to the items. Anything else you want to have addressed? This is the time, people.
Well, I think we have 10 minutes or so. One thing that used to be in the roadmaps but has disappeared is the getting rid of Corba thing.
Oh. Okay, who is impacted by the oldness of Corba?
Everyone in a short while, probably, or maybe not.
We discussed it. Just to give you the picture that I have tried to push, right? So Corba is still maintained, right? We, as a collaboration, pay the maintainer of OmniOr to keep it up to date for us. And at the moment when Duncan doesn't want to maintain it anymore, we decided already that we will just take the source code, maintain it ourselves. Because
In live support mode?
Yeah, end of life support. So essentially, we are in a good place, OmniOrb-wise, because over the past 5 years we had only, if I remember correctly, 3 bugs. One serious bug that had to do with the ARM platform, the Apple people, and 2 other minor bugs, if I remember correctly.
You ask who's held back by that? Any language younger than 20 years probably doesn't have a CORBA bindings implementation.
Okay, can I point to Theo, who has already almost implemented everything that OmniOrb does in Rust? Yeah, so...
Thomas, maybe.
Yeah.
Yeah, so
Okay,
I tried
okay.
to make a binding in Rust to OmniOrb, but it's starting to get complicated because of the C++ binding is not trivial in Rust. But I don't know, it's working, so I only have the client side, but just about the CORBA replacement, I don't really think that we should get necessarily rid of CORBA, but we definitely should get rid of the CORBA types leaking through the CPP API, and that's what I wanted to add.
Yeah.
I think that's actually the C++ high-level API proposal, which would hide all the CORBA stuff from everyone, and then replacing the transport is, I mean, not trivial, of course, but doable.
There's a comment from... Okay. Go ahead. Then,
Yeah, so
then we'll
I think that the last time I asked about it, that was also basically, I think, the biggest issue, that it's leaking everywhere in the code. So I think if we focus first on just abstracting it away within Tango, then it's way easier to replace it if needed at some point, right?
Yes.
That good?
Yes, small comment about CORBA. We have people from CERN in the room, and maybe if they look at Tango and will try to use it, they will look to use CORBA, and they say it's old, we don't really want to use it.
Yeah, only because it's old doesn't mean it's bad. Look at me, I'm old.
Not everybody like you, unfortunately.
Yeah, no. Okay, give you that.
One of the problems here is that this leaking is a very nice way of saying it. It's basically, it's completely exposed to you, the CORBA types. It's like if you do C++ device servers and you do a command with a def string array like I showed, the def string array is a CORBA object you get. And why was it done like that back then? Well, it's the fastest way to get the data to you. If we do any conversion, if we do any abstraction, well, okay, not if we do any abstraction, but if we do any conversion, it will be slower. So we have to be really careful there to like still keep it the fastest possible. But yeah, of course, this can be done with C++ high-level API, and then we switched PyTango over, and then everyone else has to maybe do a bit more than regenerating Pogo, but...
Which, in essence, it means you all have to touch your refactor your CPP Tango devices.
Well, it would be an option, I think.
Be careful for what you ask.
So yeah, if we have a sponsor, okay, so who is...
Yeah. So is that it, or is there more? Too much already. It's already too much, of course. Of course. So shall we... Alex, 1 minute. Shall we already go and prioritize things? What do you want the most? And I think we just take a vote. It's a democratic collaboration, right? Sorry?
We don't need to prioritize.
No? Not yet? Oh, we don't have a sponsor anyway.
We just need sponsors.
I wouldn't go into that today, to
yeah,
be fair.
okay.
I think it's good to collect ideas in this session.
Good.
And probably it's enough. in my
Gotcha.
opinion.
Alex?
Yeah, well, to CORBA replacement, and I think I understand Hans correctly, I also advise to implement abstract layer. So we did it already, although we made this experience with LabVIEW, CS framework, so it was LabVIEW-based framework for automation, and we released strong on DIM, maybe CORBA, whatever, and at some point that was not supported. And the next generation, suggestion of CS framework was made in this way. You have abstract level, and you can adapt each protocol suitable for industrial communication. You just add a plugin, and that's it. So, and you need some web protocol, or just write a web protocol. I would really recommend it to go this way.
We have the Tango REST thing already. Have you looked into it? Could be an option.
Or the GraphQL.
Or GraphQL, or Tango GQL Ariadne. Right? I think that nowadays Tango GQL Ariadne is the go-to interface between whatever web, for instance, and Tango devices. It can do subscriptions, and it does everything for you. It's really nice. Taranta is based on it, so it works no, it doesn't work quite well. It works very well, thanks to our friends at Max4. So yeah, I understand that we lack this interface to all applications in the universe, right? There is no standard, right? I think that is what it boils down to. Perhaps we should promote Tango GQL more.
One thing I would like to bring up is that we're using C++, is that a problem for anyone? Like discussing that with like IT folks who know how computers work?
I mean, what I recently noticed that you can see that some modern stuff does just not really exist for C++ anymore. So while it is still used in a lot of places, in the long term, that can well be an issue. Yeah, so in our case, it was we had to interface with an S3 backend, and there are libraries available, but they are almost unmaintained. So that's one example where you can basically find nothing really usable in C++ anymore.
Microphone. Here, use this one. Use it.
But I mean, you could just use...
Does it work?
You could just use PyTango, or?
No, there was more a remark on C++ in general, not directly interfacing with Tango.
Okay. No problem.
Okay. Is anybody opposing anything of that? Or do you say the more the better?
I think that's not very well specified out.
No, well, I try to summarize everything. So let's take that as future items, right? Like, no, I don't know.
Roadmap ideas as it's
like
called.
That,
yeah.
Right? Same thing. We added to the roadmap. Lorenzo's having a thought.
Posing something.
Of course.
Just a comment, because if you switch back to the previous list, the one editing online nowadays, and your question is anyone or prioritize, etc. I think every single bullet here has to go through technical discussion and improvement.
Of course. So perhaps to summarize, if you propose something here, right, that is now on that list, that will be will be discussed, I would suppose, at a future kernel meeting, right?
Where we the place, right? Where we can discuss these ideas.
Yeah, that's a place to discuss. Yeah. But we can discuss quite a lot stuff. But if there's no sponsor, nothing will happen.
Thanks for guardrailing everything.
Yeah, I mean, I'm happy to discuss, but yeah.
Just one thing before we start wrapping up this session. So we've been talking about roadmaps ideas. You have presented it in the form of slides at the moment.
Yeah.
Is there a place where the roadmap is available to the community and maintained officially?
Sorry, you're breaking up. The answer is no, not at the moment, but I appreciate that question. Yes, there should be. I wonder where. I turn to Renald usually when such a question comes up.
Yeah, there is a page on the web page.
Okay. Yes.
I put it on the chat.
Hold on. Yes, there
I'm not
is.
sure if it's. I think we.
There
We
is.
updated
heavy
it.
out of date.
Which chat, Renald?
On the Zoom chat.
Zoom chat. Am I in the wrong Zoom room? Yeah, I just clicked on it. I have the chat here. There's no
Ah,
message.
sorry. I'll do it again. I was not put. Yeah.
There it is. Okay, so let's have a look. There's our roadmap. I knew we had a roadmap. It's actually accessible through the Tango Controls org website.
And it's heavily out of date.
It is maintained.
Okay. Okay.
It
That's
is
the
maintained.
official answer.
Yeah, that's the official answer. And yeah, so we're going to update it after this community meeting, I promise. I'll take care of that. So, but I'm hesitant to put your ideas, where's that? To put your ideas already there before we have discussed it at the kernel meeting, right? To kind of really figure out what do you really want.
And
right?
to have fleshed out the idea.
Yeah. And found a sponsor. Damien?
So, just a question on the process. So
Sure.
we bring it up on a kernel at a kernel meeting, but I mean at what point? I mean, because let's say I want to sponsor something.
Yeah.
Should I write the RFC, get started, and then I go to the kernel meeting, or I go to the kernel meeting first?
I would think you want to start discussing in the kernel meeting first. We'll discuss an issue. You have some design document, and I think after it's approved, we can start the RFC process because that's very formal. And if you want to do it like that, yeah, go for it. But then, yeah, I think that is the decision. If we're going to do it, should then not be like influenced by you having already written the RFC. Let's say.
I think it comes down to, of course, you can do it in your own time, of course, and you can finish all the work on a feature branch. Of course, you can do that. The problem is, have you thought about the other facilities, how they are impacted by it? And that is what I believe the discussion at the kernel level will help us figure out. So, yes, have an RFC ready. That's fantastic. Why not? Right? Because that gives us some meat to chew on and the bone to chew on at the kernel meeting. Right? And then we can perhaps form a work group, a subset of the kernel people, to actually who are interested in moving this forward, because these people then can actually take up whatever you have already implemented, because at the kernel we agreed to take this on and figure out, okay, the implementation is going in the right way or perhaps not. Or
but I also think that like on this big feature things, maybe we should really have a written down workflow for.
Oh, sorry.
A written down process where like, hey, if I want to get really big shit done, how do I do it? Because right now this is kind of like in the flow. It's like depends on who's on the stage.
Yeah, it's ad hoc, right? And if you propose something in Rust, I will say no.
Okay.
No, I won't say no. Yeah.
Quickly, Yury, and then we need to wrap up.
I probably can suggest you, if you have such an idea, first call SIG meeting, collect people. We will discuss it for 5 days. Then we will go or not go, and then start sponsoring.
Yeah.
Because like what kernel meeting is 1 hour, and we have also first report on our tasks, blah blah blah.
Yeah.
Then we have 5 minutes.
Yeah, true.
For big. They first just start SIG meeting. We did it twice, like this year.
And to be fair, it is okay to have a SIG meeting online, right? If the facilities are concerned about travel costs and everything, but it has shown time after time that these SIG meetings face-to-face, to make the case for the face-to-face meetings, are much more productive. So the SIG meeting incurs a cost and amount of time for travel, being there. We need a host and so on and so forth. TI.
Okay, Thomas, super quickly because we need to wrap up.
I think we should be very cautious about having SIG meeting after SIG meeting and having all these ideas and not getting any sponsors to actually implement it.
The sponsor should be like, I mean, actually, I think it should be decided that we do it, and then at the SIG meeting, we can figure things out, for example, like the C++ high-level API.
Yeah.
If there's a sponsor and we say we want to do it, yes, then that's the point for the SIG meeting.
Perhaps that's the process. Come to the kernel meeting. I think, okay, here's the ad hoc process. We will announce on the kernel mailing list, if we discuss one of the items, if we put it on the agenda, you are free to put one of the items on the agenda. We can't discuss 5 of them at the same kernel meeting. So if there is already an item on the agenda, no go, right? Pick the next kernel meeting, put your item on the agenda. Then we discuss it, then we agree, go, no go.
No. We discuss it. When you make an issue, we flesh out all the details, and then we have at some point we decide.
How do we find the sponsor? So the person who suggests the item is automatically sponsor?
No. It's not very helpful without sponsor, of course.
Yeah.
Okay. Time out.
Yeah.
I think let's not make up processes on the spot.
Why not?
There's a dangerous slippery slope. But that's great to be collecting ideas, and I think that was the purpose of the session. And I think mission goal achieved. So thank you very much, Thomas and Thomas. Thanks for leading the discussion with patience, and thanks everyone for contributing ideas. And I think this is the end of the last talk for this meeting. So give them a big applause.
Okay. Thanks for the last session. Thanks, Marco, for chairing it. All good things come to an end, and the 14th Tango community meeting too. So now I will do a quick wrap-up of what have been done here. Okay, a little bit insight on the numbers. So we were 84 participants, 61 participants here in person at Alba, 23 remote. All these participants were coming from 27 different institutes, organization, companies, and we have 48 talks. And I would like to thank all the speakers for taking the effort to prepare these amazing presentations. They were of very good quality, and we all know how much work it was. Yeah, so thank you very much to all the speakers. There were also a few speakers who have prepared multiple presentations. Yeah, thank you for them. A big thanks to the live demos. So we have asked them an impossible thing. So 2 weeks before the meeting, we came with the idea based on the survey. There was a big interest in this kind of session. So thanks to Benjamin, thanks to Anton, thanks to Sergi, thanks to Thomas Braun and Thomas Ives. Thanks Yury also for chairing this, and I hope it was useful for everyone. We have learned many advanced features in Tango. I would also like to thank Katerina Viscari, who accepted to give the talk. It was also very interesting to start. Big thanks to chairs, yeah, because they have done excellent work. Yeah, so I think we didn't have a bigger delay than 5 minutes in any of the sessions. I think we all appreciate that. Also the remote participants, and it was great work, yeah, that you have done. So thank you for this. And I would like to invite here on the stage one person, Irene, because Irene is actually the organizer of the meeting. And I would like to, yeah, let's continue, yeah, this warm applause. This was a lot of work, a lot of organization. We have started many months ago. And I think she has done a wonderful job. It was, well, very smooth, and I didn't have to do anything, yeah? Thank you, Irene. There was one more person from that was also helping in the organization, which is who is Anna Belen from the communication outreach team at Alba. She is not here, but I would like to also acknowledge her help, and also the colleagues that help in preparing the program, Johan from Sarao, Yury from Desi, and Sergi, who have helped a lot in preparing this interesting program. Also, we got a lot of support from the computing division, so without help from Oscar, also it wouldn't be possible yet to make this meeting. And the biggest thanks are to all of you, because without you here, the meeting wouldn't be possible. Yeah, so we are 61 participants here in person. Thank you all for coming, for taking your time. We all have busy agendas, we have busy schedules, and since you are here, it just reflects the importance of the Tango project, the importance of the topic that we were discussing here. Thank you a lot. Thank you to the remote participants for connecting. Yeah. And this is not the end. There is still a visit, so many of you will participate in the visit to Alba. Yeah, I hope it will be interesting to you to better know our facility. And we have still 2 workshops. Tomorrow we start at 9 with archiving databases. We have 23 in-person participants, 8 remote. The meeting is organized by Sergi and the HDB++ community. And in parallel, we have a Sardana workshop with 20 participants and 9 remote participants, which is organized by Oriol and the Sardana community. So I hope you still enjoy the stay at Alba. And thanks to the Tango community for giving us the opportunity to organize this meeting. And I hope you have enjoyed it. You have enjoyed being at Alba. It was a pleasure for us to host you here. You have enjoyed Barcelona and the surroundings. And those of you who are leaving today, I wish you a safe trip home. And see you next year in Krakow.